Right now, astronauts aboard the International Space Station are aging slower than you are. Not by much, only about 0.007 seconds over 6 months, but measurably, verifiably slower. Their clocks tick slower. Their cells divide slower. Their heartbeats occur at longer intervals. Time itself runs at a different rate for them than for you. Yet if you ask them whether time feels slower, they would say no. Their experience of duration is identical to yours. Seconds feel like seconds. Hours feel like hours. 6 months in orbit feels exactly like 6 months on Earth. From their perspective, nothing is strange. This is the astronaut paradox. Time dilation is real. We can measure it with atomic clocks. We account for it in GPS satellites. We've verified it in countless experiments. But it's also completely imperceptible from the inside. The person experiencing slower time never feels it slowing down because everything about them slows proportionally. Their perception, their thoughts, their awareness of duration. This suggests something profound about the nature of time. It's not a universal river carrying all things forward at the same rate. It's observer-dependent, relative, variable. Two people can experience different amounts of time between the same two events, and both experiences are equally valid. There is no absolute timekeeper, no universal clock ticking away somewhere defining what now means for everyone. Einstein discovered this in 1905, and physics has confirmed it ever since. But the philosophical implications remain unsettling. If time can run at different rates depending on your motion or location in a gravitational field, what does that mean for your experience of reality? Are you living in slow motion right now without knowing it? Is someone else experiencing time faster? And how would you ever know? Tonight, we explore the strange reality of time dilation, why it happens, what it feels like from the inside, which is to say, normal, and what it means to exist in a universe where time itself is negotiable. In 1905, Albert Einstein published a paper titled On the Electrodynamics of Moving Bodies that fundamentally changed our understanding of space and time. He was 26 years old, working as a patent clerk in Bern, Switzerland, and he was about to demolish assumptions that had stood for centuries. Before Einstein, time was thought to be absolute. Newton had described time as flowing uniformly throughout the universe, independent of anything else. A second on Earth was a second everywhere. The past, present, and future were universal categories that everyone experienced identically. Time was the stage on which events occurred, unchanging and impartial. Einstein realized this couldn't be right. He was thinking about light and how it behaves, specifically about a problem that had troubled physicists for decades. Light travels at a specific speed, about 300,000 kilometers per second, and this speed seemed to be constant regardless of how you measured it. Whether you were moving toward a light source or away from it, light always approached you at the same speed. This was bizarre. If you're in a car traveling 100 kilometers per hour and another car passes you going 120 kilometers per hour, that car appears to be moving 20 kilometers per hour relative to you. This is how velocities normally add and subtract. But light doesn't work this way. If you're traveling toward a light beam at half the speed of light, the beam doesn't approach you at 1.5 times the speed of light. It approaches you at exactly the speed of light, the same speed everyone else measures. Einstein asked a simple question. What if the speed of light is always constant because time and space adjust to make it so? What if moving objects experience time more slowly and distances contract so that light always crosses those distances at the same rate? This was the insight that changed everything. Time is not fixed. It adjusts based on your motion. And if time adjusts, then simultaneity, the concept of events happening at the same time, becomes relative. Two events that are simultaneous for one observer might occur at different times for another observer moving at a different velocity. There is no universal present moment. The mathematics worked out perfectly. Einstein showed that time dilation and length contraction arise naturally from requiring the speed of light to be constant in all reference frames. The equations were simple and elegant, but the implications were radical. Time itself is not what we thought it was. To understand why time slows down with motion, imagine a simple clock made of light. This clock consists of two mirrors facing each other with a beam of light bouncing back and forth between them. Each bounce represents one tick of the clock. The time between ticks depends on the distance between mirrors and the speed of light. Now imagine this clock is on a spacecraft moving past you at high speed. From your perspective watching the spacecraft go by, the light beam doesn't just bounce straight up and down between the mirrors. It also moves sideways with the spacecraft. The light traces out a diagonal path, traveling a longer distance between bounces than it would if the clock were stationary. But the speed of light is constant. Cannot go faster to compensate for the longer path. If the light is traveling a longer distance at the same speed, it must take more time to complete each bounce. From your perspective, the moving clock ticks slower than an identical stationary clock. Time has dilated for the moving clock. This is not an optical illusion or a measurement error. The moving clock genuinely ticks slower. If you could observe every process on the spacecraft, heartbeats, chemical reactions, radioactive decay, thought processes, all of them would proceed more slowly than identical processes on the ground. Time itself runs slower for the moving spacecraft. But here's what makes this genuinely strange rather than just counterintuitive. From the perspective of someone on the spacecraft, their clock is not moving. It's you and the ground that are moving relative to them. From their perspective, it's your clock that should be ticking slower because you're the one in motion relative to them. And they're right. From their reference frame, your time is dilated, not theirs. Both perspectives are correct. You observe their clock running slow. They observe your clock running slow. This seems like a contradiction, but it's not because you're not comparing the clocks in the same way. The relativity of simultaneity means that when you think it's now for them, they think it's a different now for you. Your coordinate systems are rotated relative to each other in spacetime, and this rotation makes the comparison asymmetric. This is why special relativity is called relativity. Motion is relative. There's no absolute rest. And because motion is relative, time dilation is also relative. There's no universal time ticking away independent of observers. Time is what clocks measure, and clocks run at different rates depending on their motion relative to each other. Einstein's theory seemed bizarre, but it made specific predictions that could be tested. If time dilation was real, certain measurable effects should occur. And they did. One of the first confirmations came from observations of cosmic rays. High-energy particles from space constantly bombard Earth's atmosphere, creating showers of secondary particles, including muons. Muons are unstable particles that decay quickly. Their half-life when at rest is about 2.2 microseconds. At this decay rate, even traveling at near light speed, muons created in the upper atmosphere should mostly decay before reaching the ground. But they don't. Muons reach ground-level detectors in large numbers. The explanation is time dilation. From our reference frame on Earth, the muons are moving so fast that time slows down for them. What would be 2.2 microseconds for a stationary muon becomes tens of microseconds for a muon traveling at 99% the speed of light. So they live longer from our perspective and reach the ground before decaying. From the muon's reference frame, the explanation is different but equivalent. The muon experiences its normal 2.2 microsecond lifespan. But due to length contraction, the distance from atmosphere to ground is compressed to a much shorter distance in the muon's frame. So the muon travels this contracted distance within its normal lifespan. Same physical result, two different but equivalent explanations depending on reference frame. This is the hallmark of relativity. Both descriptions are correct. There is no preferred perspective. As technology improved, more direct tests became possible. In 1971, physicists Joseph Haffel and Richard Keating flew atomic clocks around the world on commercial aircraft and compared them to reference clocks on the ground. The flying clocks experienced less time due to their velocity and higher altitude. When the flights completed, the clocks showed measurable differences matching relativity's predictions with remarkable precision. Today, time dilation is not theoretical speculation. It's engineering fact. GPS satellites must account for time dilation or navigation would be impossible. Particle accelerators observe time dilation in every experiment. The International Space Station astronauts accumulate measurable time differences over months in orbit. Every test confirms Einstein's predictions. Time dilation is real, but the philosophical puzzle remains. If time genuinely runs at different rates, why doesn't the person experiencing slower time notice it? Why does time always feel the same from inside every reference frame? Special relativity describes how time and space behave for objects moving at constant velocities relative to each other. The key insight is that space and time are not separate entities but are woven together into a four-dimensional spacetime. How you move through space affects how you move through time. Imagine spacetime as having four dimensions: 3 of space, up-down, left-right, forward-backward, and 1 of time, past-future. Every object traces out a path through this four-dimensional spacetime called a world line. Your world line is the complete history of your spatial position over time. There's a deep connection between motion through space and motion through time. Everything moves through space-time at the speed of light. Always. This might sound strange because you're probably sitting still right now, not moving at 300,000 kilometers per second. But you're moving through time at roughly 1 second per second, and that motion through time counts as motion through space-time. When you start moving through space, getting up and walking, driving, flying, some of your motion through space-time gets redirected from the time dimension into spatial dimensions. You're still moving through space-time at the speed of light, but now that motion is divided between space and time rather than being entirely in the time direction. This is why time slows down when you move. The faster you move through space, the slower you move through time because your total motion through space-time is constant. At everyday speeds, this effect is negligible. But as you approach the speed of light, more and more of your space-time motion goes into spatial dimensions, leaving less for temporal motion. Time slows down significantly. There's a mathematical relationship that captures this precisely. If you're moving at velocity v relative to another observer, time for you runs slower by a factor called gamma, represented by the Greek letter gamma. The formula is gamma is equal to 1 divided by the square root of 1 minus v squared over c squared, where c is the speed of light. At everyday speeds, v is tiny compared to c, so the denominator is very close to 1, making gamma barely larger than 1. Time dilation is negligible, but as v approaches c, the denominator approaches 0, making gamma grow without bound. Time dilation becomes extreme. For example, at 90% the speed of light, gamma is about 2.3. Time runs about 2.3 times slower. A journey that takes 1 year for the traveler takes 2.3 years for stationary observers. At 99% light speed, gamma is about 7. At 99.9% light speed, gamma is about 22. At 99.99% light speed, gamma is about 70. The closer you get to light speed, the more dramatic time dilation becomes. This explains why nothing with mass can reach the speed of light. As you accelerate closer to light speed, time dilation increases without limit. From an outside perspective, you would appear to move slower and slower through time, asymptotically approaching frozen motion. It would take infinite energy to actually reach light speed because you'd be trying to stop your motion through time entirely. Light itself doesn't experience time. Photons move through space at light speed, which means all their spacetime motion is in spatial dimensions with none left for time. From a photon's perspective, if such a concept makes sense, no time passes during its journey. A photon emitted by a distant star and absorbed by your eye billions of years later experiences zero elapsed time in its own reference frame. It is created and destroyed in the same instant from its perspective. Special relativity handles time dilation for motion, but Einstein wasn't finished. 10 years later, in 1915, he published his general theory of relativity, which extended these ideas to include gravity. And gravity, it turns out, also dilates time. Einstein's key insight about gravity was that it's not really a force. It's the curvature of spacetime caused by mass and energy. Massive objects like planets and stars warp the fabric of spacetime around them, creating a curved geometry. What we experience as gravitational attraction is actually objects following the straightest possible paths through curved spacetime. This curvature affects time. The stronger the gravitational field, the more time slows down. If you're deep in a gravitational well, close to a massive object, time runs slower for you than for someone farther away where gravity is weaker. This is gravitational time dilation. The effect is again described by a factor, though the formula is more complex than special relativity's gamma factor. Near Earth's surface, the gravitational time dilation is small but measurable. Time runs about 3 parts in 10 billion slower on the ground than in orbit. Over 6 months, this accumulates to about 22 microseconds of difference. But wait, the ISS astronauts are also moving fast in orbit, which causes time to slow down from special relativity. So do they experience more time or less time than people on Earth? It depends on which effect dominates. The astronauts orbit at about 7.6 kilometers per second, which causes special relativistic time dilation of about 8.3 microseconds per day. But they're also 400 kilometers up where gravity is weaker, which causes gravitational time dilation of about 14.4 microseconds per day in the opposite direction. They age faster due to weaker gravity. The net effect is about 6.1 microseconds per day faster. Over 6 months, they age about 1 millisecond more than people on the ground. Wait, didn't we say earlier they age slower? Actually, different sources calculate this differently depending on what comparison they're making. The point is both effects matter, and for precise calculations, you must include both special and general relativity. The takeaway is that time genuinely runs at different rates depending on both motion and gravitational environment. The most extreme gravitational time dilation occurs near black holes. At the event horizon of a black hole, time dilation becomes infinite relative to a distant observer. An object falling toward a black hole appears to slow down as it approaches the horizon, eventually seeming to freeze and never quite cross. But from the falling object's perspective, it crosses smoothly in finite time. The object experiences normal time locally while the distant observer sees infinite time elapse. This creates a profound asymmetry. You could fall into a black hole, cross the horizon, and reach the singularity in seconds from your perspective. But to a distant observer, you never cross. You appear frozen at the horizon forever. Both descriptions are correct in their own reference frames, but they are incompatible descriptions of the same event. This is general relativity at its most extreme, revealing that time is not just relative to motion but also to gravitational environment. The universe has no universal clock. Time is local, varying from place to place and observer to observer. The most direct daily evidence for time dilation is GPS technology. GPS relies on precise timing. Satellites broadcast their positions and the exact time according to their onboard atomic clocks. Your GPS receiver picks up signals from multiple satellites, calculates how long each signal took to arrive based on the time delay, and uses those distances to triangulate your position. This only works if the satellite clocks are accurate. But they're not accurate from the ground's perspective because of time dilation. The satellites orbit at about 20,000 kilometers altitude, traveling at about 14,000 kilometers per hour. Two relativistic effects matter. Special relativity. The satellite's velocity causes their clocks to run about 7 microseconds per day slower than ground clocks. General relativity. The satellite's higher altitude places them in a weaker gravitational field, causing their clocks to run about 45 microseconds per day faster than ground clocks. The gravitational effect dominates. Net result. Satellite clocks run about 38 microseconds per day faster than ground clocks. This doesn't sound like much, but light travels about 30 centimeters in a nanosecond. In 38 microseconds, light travels about 11 kilometers. If we didn't correct for this, GPS would accumulate positioning errors of over 10 kilometers per day. The system would be unusable. Engineers handle this by programming the satellite's clocks to tick at a slightly slower rate than they would naturally. The clocks are set to 10.22999999543 MHz instead of the ground frequency of 10.23 MHz. This compensation exactly accounts for both relativistic effects. When the satellites are in orbit, their slow clocks speed up due to relativity and end up synchronized with ground time. Every GPS device in every phone and car relies on this correction. Every navigation system accounts for relativity. Time dilation is not abstract theory. It's engineering necessity. Without Einstein's equations, modern navigation fails. This should be astonishing. The fundamental nature of time is strange enough that we must warp our technology to accommodate it. Yet we do this unconsciously every time we check our location. Relativity is so deeply embedded in modern life that we don't even notice we're using it. Here is the central mystery. Time genuinely runs at different rates. We can measure this. We build technology around it. Astronauts' clocks tick slower. Their heartbeats occur at longer intervals. Their cells divide more slowly. Everything about them happens at a reduced rate relative to ground observers. And yet they feel nothing. Time doesn't feel slow. Duration feels normal. 6 months feels like 6 months. How is this possible? The answer lies in what consciousness is and how it relates to physical time. Your experience of time passing is not a direct perception of some external time. It's constructed by your brain from neural processes. The rate at which you experience time depends on the rate at which your neurons fire, neurotransmitters cross synapses, and thoughts form. All of these processes are physical events occurring at specific rates measured by your local clock. When your local time slows down due to motion or gravity, all physical processes slow down proportionally, including the processes that create your conscious experience. Your neurons fire slower. Your thoughts form slower. Your subjective sense of duration stretches out. But you can't detect this because you have no external reference. You're measuring your slower time with your slower clock, so the measurement always comes out normal. It's like trying to measure a shrinking ruler with itself. If the ruler shrinks, so does the measurement of the ruler's length. You can't detect the change from within the system because everything changes together. This creates an interesting philosophical situation. From an external perspective, you're experiencing time slowly. An hour for you might be 2 hours for someone else. Your thoughts are forming at half speed. Your experiences are drawn out. But from your internal perspective, nothing is different. The hour feels like an hour. Your thoughts feel normal speed. Your experiences feel standard. Which perspective is correct? Both are. There's no absolute rate at which thoughts should form or experiences should occur. The only thing that matters is your local time, and relative to your local time, everything always proceeds normally. This explains why astronauts don't feel time slowing down. This explains why a traveler near light speed wouldn't feel time dilation. This explains why someone falling into a black hole wouldn't feel time stretching out even as distant observers see them frozen. Your experience is always synchronized with your local time frame, and you have no way to perceive the difference between your local time and someone else's distant time except by comparing clocks afterward. This leads to one of the most famous thought experiments in relativity, the twin paradox. One twin stays on Earth. The other twin travels in a spacecraft at near light speed to a distant star and returns. From Earth's perspective, the traveling twin's time is dilated. They age slower. When they return, they're younger than the stay-at-home twin. But wait, isn't motion relative? From the traveling twin's perspective, Earth is moving away and then approaching. Shouldn't Earth's time be dilated from the traveler's perspective? Shouldn't the traveling twin see the Earth twin as younger? This is the paradox. Both twins observe each other moving, so both should see the other aging slower. How can one definitely be younger when they reunite? The resolution is that the situation is not symmetric. The traveling twin must accelerate to turn around and come back. During this acceleration, they switch reference frames. The stay-at-home twin never accelerates and remains in a single inertial reference frame the entire time. This asymmetry resolves the paradox. During the acceleration phase, from the traveling twin's perspective, Earth's clock suddenly jumps forward. The relativity of simultaneity means that what counts as now for the traveler shifts dramatically during acceleration. When they finish turning around, they find that far more time has passed on Earth than they experienced. The traveling twin really is younger. From the traveling twin's subjective experience, nothing strange happens during the journey. Time feels normal throughout. They don't feel time slowing down. They don't feel themselves aging slowly. They eat meals, sleep, think, experience life at what seems like normal rates. Only when they compare ages with their twin afterward does the difference become apparent. The traveling twin experienced less time. From an objective standpoint, fewer events occurred in their life. Fewer heartbeats, fewer breaths, fewer thoughts. But from their subjective standpoint, the journey felt completely normal in duration. This is the paradox of time dilation. It's objectively real but subjectively imperceptible. If time is relative and different observers experience different durations, can observers disagree about the order of events? Can one observer see event A happen before event B, while another sees B before A? The answer is complicated. For events that can influence each other, events connected by light signals or slower than light causes, all observers agree on the order. Relativity preserves causality. If event A causes event B, every observer sees a before B. The universe doesn't permit causal paradoxes where effects precede causes. But for events that cannot influence each other, events separated by such distance that light hasn't had time to travel between them, different observers can disagree about their order. If two events occur on opposite sides of the galaxy and are separated by less time than it takes light to cross the galaxy, some observers might see event A first while others see event B first. Both perspectives are valid. This reveals something profound about simultaneity. The concept of now only makes absolute sense locally. Your now is well defined in your immediate vicinity, but extending now across vast distances becomes ambiguous. Different observers moving at different velocities will have different surfaces of simultaneity, different sets of distant events that they consider to be happening now. This means that on cosmic scales, there is no universal present moment. The question, what is happening on a planet orbiting Alpha Centauri right now, has no absolute answer. The answer depends on your reference frame. Different observers moving at different velocities would identify different moments at Alpha Centauri as simultaneous with your now. This should be deeply unsettling if you think about it carefully. The idea that the present moment is relative, that simultaneity is observer-dependent, that there's no absolute now spanning the universe, these implications challenge deep intuitions about reality. We're used to thinking of time as a universal flow that everything participates in together. But that's not how time works. Time is local, relative, frame-dependent. Before exploring extreme scenarios, we need to understand a crucial concept: proper time. Proper time is the time measured by a clock traveling with you. It's the time you experience directly, the time that governs your aging, your thoughts, your biological processes. This is distinguished from coordinate time, which is the time measured by a distant observer watching you from their reference frame. When physicists say time slows down, they mean that your proper time, the time you experience, accumulates more slowly relative to someone else's coordinate time. But from your perspective, your proper time always flows normally. You always experience 1 second per second of your own proper time. The discrepancy only appears when proper times are compared between observers who have traveled different paths through spacetime. This is analogous to spatial distance. If you and a friend start at the same location and walk different paths to a destination, you'll cover different distances even though you end up at the same place. Your odometers will show different readings. Similarly, if you and a friend start at the same spacetime event and take different paths through spacetime to reunite, you'll accumulate different amounts of proper time. Your clocks will show different readings when you meet again. The crucial difference is that in space, the straight line is the shortest distance between 2 points. In spacetime, the straight line, the path of constant velocity with no acceleration, is the longest proper time between two events. Paths that accelerate or travel through strong gravity accumulate less proper time. This is why the traveling twin in the twin paradox ages less. They take an accelerated path while the stay-at-home twin takes a straight path through spacetime. This inversion, shortest distance in space, longest time in spacetime, comes from the minus sign in the spacetime interval formula. Spacetime geometry has different rules than spatial geometry, and these different rules create all the strange effects of relativity. Understanding this, we can now explore what extreme time dilation actually means experientially and physically. Imagine you board a spacecraft capable of traveling at 99.99% the speed of light. You take a journey to a star 100 light-years away and return. The round trip is 200 light-years at nearly light speed. So from Earth's perspective, the journey takes just over 200 years. When you return, Earth has aged 2 centuries. Everyone you knew is dead. Civilizations have risen and fallen. Technology has transformed beyond recognition. But how much time did you experience? At 99.99% light speed, the time dilation factor gamma is about 70. Time runs 70 times slower for you than for Earth. The 200-year journey from Earth's perspective is only about 2.8 years from yours. You aged less than 3 years while Earth aged 2 centuries. From your perspective, you didn't travel for 200 years at slow speed. You traveled for 2.8 years at high speed through contracted space. The 100 light-year distance to the star was compressed to less than 1.5 light-years due to length contraction. You crossed this shortened distance in less than 3 years at near light speed, then returned the same way. The journey felt short because space contracted, not because time dilated, from your perspective. Same journey, 2 completely different descriptions. Earth sees you traveling 200 years through normal space experiencing dilated time. You see yourself traveling less than 3 years through contracted space experiencing normal time. Both descriptions are mathematically correct and observationally verified by what each observer measures. And throughout your journey, time felt normal. Years passed at the rate years pass. Days felt like days. You aged normally, cells dividing, hair growing, memories forming, all at the rate these processes always seem to proceed. Nothing felt slow or stretched out or strange. Only upon return, when you compared your age to Earth's age, did the difference manifest. This scenario is not science fiction. If we had the technology to accelerate to such speeds, which would require enormous energy, this is exactly what would happen. Time dilation at high velocities is not speculation. It's verified physics that we've tested with particles in accelerators. The only thing preventing us from testing it with humans is engineering limitations, not physical impossibility. But let's examine this scenario more carefully to understand what the experience would actually be like. During your journey, you would not feel like you're in slow motion. Your heart would beat at what feels like normal rate to you. Your thoughts would form at what seems like normal speed. If you watched a clock on board your spacecraft, seconds would tick by at the rate seconds always tick for you. The key insight is that everything about you slows down together. Your metabolism, your neural processes, your cellular division, your perception of duration, all synchronized, all running at the same reduced rate relative to Earth. Because everything slows proportionally, nothing feels slow from your perspective. It's like a video played at half speed. The people in the video don't notice anything wrong because their thinking and speaking are also slowed down by the same factor. However, if you could somehow observe Earth during your journey, you would see something extraordinary. Earth would appear to be in fast forward. Years would pass on Earth in what feels like months to you. You'd watch seasons cycle rapidly. You'd see construction projects completed in time-lapse. If you had a powerful enough telescope to see individual people, they'd appear to move in jerky fast motion, living their lives at accelerated pace from your perspective. This asymmetry is crucial. You see Earth's time speeding up while Earth sees your time slowing down. Both perspectives are valid because you're comparing times across different reference frames. During your outbound journey, you and Earth are moving apart, and the relativity of simultaneity means you're not synchronized. What you consider now on Earth is different from what Earth considers now for you. The really dramatic effects occur during your turnaround. When you decelerate, stop, and accelerate back toward Earth, your reference frame changes. The relativity of simultaneity shifts dramatically. From your perspective, Earth's clock suddenly jumps forward. What was the distant future a moment ago is now the present. This is when most of the time difference accumulates from your perspective. The outbound and inbound journeys contribute some time dilation, but the turnaround is when Earth's time leaps ahead. By the time you return to Earth, 200 years have passed there while you've aged less than 3 years. This is not a mistake or paradox. This is the mathematics of space-time geometry working out exactly as it should. The twin who travels experiences less proper time because their world line through space-time is longer in spatial dimensions and shorter in temporal dimension compared to the twin who stays home. What would it be like psychologically to experience this? You leave Earth in, say, the year 2100. You travel for what feels like a couple years, you celebrate 2 birthdays, you go through about 700 sleep-wake cycles, you have hundreds of thousands of heartbeats. This is real time for you, genuine duration, actual aging. But when you return, it's the year 2300. Everyone you knew is dead. Your children are long gone. Your grandchildren are dead. Your great-great-great-grandchildren might still be alive, but they're elderly. The entire world has transformed. Technology is unrecognizable. Political boundaries have shifted. Languages have evolved. You're a time traveler not because you moved through time, but because you experienced less time than everyone else. From your perspective, you didn't travel to the future. You just took a journey that felt like 3 years. Earth is the one that aged rapidly, not you. But from Earth's perspective, you're the one who aged slowly, creeping through time at a fraction of normal pace, finally arriving 200 years later barely older than when you left. Both descriptions are correct. Both are verified by clock measurements. And both are completely different experiences of the same journey. This is what makes relativity so philosophically challenging. Objective physical facts, how much proper time elapsed, depend on the path taken through space-time. There's no single answer to how long did the journey take. The answer is 3 years for the traveler, 200 years for Earth. Both simultaneously true. Now consider gravity's effect. Neutron stars are incredibly dense collapsed cores of dead stars. A typical neutron star masses about 1.4 times the Sun's mass compressed into a sphere only about 20 kilometers in diameter. The surface gravity is immense, about 100 billion times Earth's gravity. This extreme gravity creates extreme time dilation. If you could somehow stand on a neutron star surface, which you can't because the gravity would instantly crush you to atomic thickness, time would run much slower for you than for someone far from the star. Gravitational time dilation at a neutron star surface is significant. Time runs about 15 to 20% slower depending on the star's exact mass and radius. Let's think carefully about what this means. If you spent 1 year on the neutron star's surface and then left to reunite with someone who stayed in orbit far from the star, they would have aged about 1.15 to 1.2 years. You'd be younger, just as in the velocity case, but now it's gravity causing the effect rather than motion. But the phenomenology would be identical to the motion case. During your year on the surface, time would feel perfectly normal to you. Your heartbeat would feel regular. Your thoughts would form at normal speed. Days would feel like days. The year would feel like a year. Nothing about your internal experience would suggest that time was running slowly. However, if you could observe your orbiting companion from the surface, you'd see something strange. They would appear to be in fast motion. Their movements would be quick. Their clock would tick rapidly. They'd be living their life at accelerated pace from your perspective. Meanwhile, from their perspective looking down at you, you'd be in slow motion. Your movements sluggish, your clock ticking slowly, your life proceeding at reduced pace. This creates an interesting situation. In the velocity case, both observers see each other's time as dilated until they reunite and account for the acceleration. But in the gravitational case, there's an asymmetry. The observer deeper in the gravitational well on the surface sees the observer higher up in orbit as time dilated faster. The observer higher up sees the observer lower down as time dilated slower. There's no reciprocal symmetry because gravity creates an absolute relationship. One person is unambiguously deeper in the gravitational well than the other. This asymmetry makes gravitational time dilation potentially more intuitive than velocity time dilation. It's easier to accept that time runs slower down here in strong gravity and faster up there in weak gravity than to accept that two observers in relative motion both see each other's time as slow. Gravitational time dilation has a preferred direction toward the massive object. Velocity time dilation is purely relative with no preferred frame. From a general relativistic perspective, gravitational time dilation occurs because massive objects curve spacetime. The curvature affects the geometry of time itself. Clocks closer to a massive object follow world lines through more curved spacetime, and these world lines accumulate less proper time compared to world lines through flatter spacetime farther away. You can visualize this with a rubber sheet analogy, though like all analogies it's imperfect. Imagine spacetime as a rubber sheet. A massive object creates a depression in the sheet. Clocks near the depression, down in the curved region, tick more slowly than clocks far from the depression where the sheet is flatter. The curvature literally affects time's rate of passage. But again, from inside the curved region, you notice nothing unusual. Your clock ticks at what feels like normal rate because you have no external reference. It's only when you compare your clock to a clock in a different gravitational environment that the difference becomes apparent. This has been measured precisely on Earth. Atomic clocks at different altitudes tick at measurably different rates. A clock in a basement runs slower than a clock on a mountaintop. The difference is tiny, only about 1 nanosecond per day for every 30 centimeters of height difference, but it's measurable with modern atomic clocks. And it matches general relativity's predictions exactly. In fact, this effect is so well established that in 2010, physicists at NIST used atomic clocks to measure time dilation caused by altitude differences of just 33 centimeters, about the height of a single step on a staircase. They could detect the difference in clock rates between someone standing on the floor and someone standing on a low stool. Gravity's effect on time is that precise and that real. There's a deep connection between gravitational time dilation and the equivalence principle, one of the foundational insights of general relativity. The equivalence principle states that the effects of gravity are locally indistinguishable from the effects of acceleration. If you're in a windowless room, you can't tell whether you're sitting on Earth's surface feeling 1g of gravity or in a rocket in deep space accelerating at 1g. The physical effects are identical. This means that gravitational time dilation and acceleration-induced time dilation are manifestations of the same phenomenon. If you're at the bottom of an accelerating rocket, time runs slower for you than for someone at the top. This is true whether the rocket is accelerating in space or sitting stationary on Earth. The acceleration and gravity are equivalent, so their time dilation effects are equivalent. This unification of gravity and acceleration through their effects on time is one of the beautiful insights of general relativity. Time dilation is not an accidental side effect of gravity. It's a necessary consequence of space-time curvature. And acceleration, which changes your path through space-time, creates equivalent curvature effects locally. This also explains why light is affected by gravity. Light doesn't have mass, so Newtonian gravity shouldn't affect it. But general relativity says gravity is spacetime curvature, and light follows spacetime's geometry. When spacetime is curved by mass, light paths curve. This is gravitational lensing, observed countless times in astronomical observations. But light is also affected by gravitational time dilation. A photon climbing out of a gravitational well loses energy, its frequency decreasing, its wavelength stretching. This is called gravitational redshift. It's not that the photon slows down. Light always moves at light speed locally. Rather, the photon's frequency is affected by moving between regions of different time dilation. Photons emitted from the surface of a neutron star are significantly redshifted by the time they escape to distant space. This demonstrates that time dilation has physical consequences beyond just clock comparisons. It affects electromagnetic radiation. It affects particle decay rates. It affects chemical reaction rates. It affects every physical process that unfolds over time. Time dilation is not merely about measurement or perception. It's about actual physical duration and how much of it accumulates along different paths through spacetime. The ultimate extreme is a black hole. Near a black hole's event horizon, time dilation approaches infinity relative to distant observers. This is not hyperbole or approximation. The time dilation factor genuinely becomes infinite at the horizon. A clock at the horizon, from a distant observer's perspective, would appear completely frozen in time. Let's think carefully about what this means. Imagine you're watching an astronaut fall toward a black hole. As they get closer to the event horizon, you see them slow down. Not gradually, dramatically. Their descent rate decreases. Their movements become sluggish. They appear to freeze, suspended forever just above the horizon, never quite crossing it. If you watched for 1 billion years, they'd still be there, barely moving, redshifted to invisibility, but never crossing. From your perspective, it takes infinite time for them to cross the horizon. They asymptotically approach it, but never reach it. The horizon is an infinitely far away in time, even though it's finite distance in space. But now consider the astronaut's perspective. From their frame of reference, nothing special happens at the horizon. They fall smoothly across it in finite time. For a large black hole, say one with 1 million solar masses like the supermassive black hole at the center of our galaxy, crossing the horizon might take only a few seconds from the astronaut's perspective. They would feel no jolt, no barrier, no indication that something momentous has occurred. They just keep falling. This creates a profound observational paradox. From your distant perspective, the astronaut never crosses the horizon. They're still there, frozen forever just above it. But from the astronaut's perspective, they crossed it long ago and are now inside, falling toward the singularity. Both descriptions are correct in their respective reference frames, yet they're completely incompatible. This isn't just a thought experiment. This asymmetry is fundamental to black hole physics. It's related to the black hole information paradox and the firewall problem, two of the deepest unsolved questions in theoretical physics. The tension between the external and internal descriptions of crossing a horizon has no agreed resolution. After crossing the horizon, the astronaut continues falling inward. They have a finite amount of proper time before reaching the singularity, maybe seconds to hours depending on the black hole size. During this time, they would experience increasing tidal forces as the difference in gravity between their head and feet becomes extreme. These tidal forces would eventually stretch them apart in a process gruesomely termed spaghettification. But even during this final descent, time would feel normal to them. The seconds ticking by would feel like seconds. Their thoughts would form at what seems like regular speed. The horror of spaghettification would unfold at normal experiential pace. There would be no sense of time slowing or stretching despite the infinite time dilation relative to distant observers. At the singularity, physics breaks down. The curvature of spacetime becomes infinite. The tidal forces become infinite. General relativity's equations produce infinities, suggesting the theory is incomplete at this regime. We don't know what actually happens at a singularity. Perhaps quantum gravity effects become important. Perhaps the singularity is resolved into something less pathological. Perhaps time itself ceases to be a meaningful concept. We simply don't know. But the journey to that point is well described by general relativity. And throughout that journey, the astronaut's proper time flows normally from their perspective while infinite coordinate time elapses from a distant observer's perspective. This is time dilation at its mathematical extreme, revealing that time is not just relative but can become arbitrarily dilated, even infinitely so, while still flowing normally for the person experiencing it. After these extreme examples, let's return to something more familiar: time dilation on Earth. Even at Earth's modest gravity and slow rotation speed, time dilation effects exist and are measurable. The most obvious manifestation is altitude. The higher you are, the faster time runs. A person living at sea level ages slightly slower than a person living on a mountain. The difference is tiny, about 90 nanoseconds per day for every kilometer of altitude, but over a lifetime it adds up to a few microseconds. Someone who lives their entire life at high altitude will be microseconds older than someone who lives at sea level, all else being equal. This has been measured directly. In the 1970s, physicists used atomic clocks in aircraft to test relativistic predictions. They flew clocks east and west around the world and compared them to reference clocks on the ground. The flying clocks experienced both velocity-induced time dilation, they were moving faster than ground clocks, and gravitational time dilation, they were at higher altitude. The combined effects matched general relativity's predictions within experimental error. More recently, ultra-precise atomic clocks have demonstrated time dilation effects from much smaller velocity and gravitational differences. Researchers have measured time dilation from walking speed, a few kilometers per hour. They've measured it from height differences of a single step. The effects are real and precisely match relativity's predictions. This means that your head is aging slightly faster than your feet. The time dilation from the 2-meter height difference between your head and feet is minuscule, about 90 nanoseconds per 80 years, but it's real. Over your entire lifetime, your head experiences more time than your feet by about 100 nanoseconds. This is absurdly small, but it demonstrates that time dilation is not just an exotic phenomenon occurring at extremes. It's happening right now in your own body at all times. Similarly, if you drive in a car, you age slightly slower than pedestrians due to your velocity. If you fly in an airplane, the velocity effect of aging slower is partially offset by the altitude effect of aging faster, but the altitude effect dominates, so you age faster during flights than you would on the ground. Professional pilots accumulate measurable time differences over their careers compared to people who never fly. These effects are completely imperceptible experientially. You cannot feel time running faster in your head than your feet. Pilots don't feel time running faster during flights, but the effects are physically real and measurable with sufficiently precise clocks. And they demonstrate that time dilation is not just about extreme scenarios. It's a ubiquitous feature of reality that affects everything, everywhere, all the time. There's one more type of time dilation worth discussing: cosmological time dilation caused by the expansion of the universe. This is less intuitive than the other types, but equally real. The universe is expanding. Distant galaxies are receding from us, and the farther away they are, the faster they recede. This is described by Hubble's law. The expansion is not galaxies moving through space, but space itself expanding, carrying galaxies along with it. This expansion affects light traveling through space. As light travels from a distant galaxy to us, the space it's traveling through expands, stretching the light's wavelength. This is cosmological redshift. The farther the light travels, the more it's redshifted. But the expansion also affects time. Events in distant galaxies appear to proceed more slowly from our perspective due to cosmological time dilation. A supernova that lasts 1 month in its local time appears to last longer when observed from Earth. The more distant the supernova, the more stretched out in time it appears. This has been measured. Type Ia supernovae have characteristic light curves. Their brightness rises and falls over a predictable timescale. But distant supernovae have stretched light curves compared to nearby ones. The stretching factor matches exactly the cosmological redshift, confirming that time itself is dilated by cosmic expansion. This means that, in a profound sense, the early universe experienced time differently than the present universe does. Events in the early universe unfolded faster, from their local perspective, relative to our current time. The entire cosmic history can be thought of as having variable time rates, with the early universe running faster and the current universe running slower when compared across cosmic epochs. This isn't the same as velocity or gravitational time dilation, but it shares the same fundamental feature. Time is not absolute. Its rate depends on context, in this case, the expansion state of the universe. And this time dilation is real enough to be measured in astronomical observations. All of these examples, velocity, gravity, cosmic expansion, demonstrate that time dilation is not theoretical speculation but empirical fact. Time genuinely runs at different rates in different contexts. This has been verified in laboratories, in aircraft, in orbit, in astronomical observations, in GPS satellites, in particle accelerators. Every test confirms Einstein's predictions. Time is relative, and yet from inside any reference frame, time feels normal because you're always synchronized with your own local time, unable to perceive the dilation directly. One of the most philosophically troubling implications of relativity is the nature of the present moment. In everyday life, we think of now as a universal instant that spans the entire universe. At this moment, there are facts about what's happening everywhere, what's occurring on Mars, in the Andromeda Galaxy, at the edge of the observable universe. We imagine that existence proceeds through a sequence of universal nows, each one containing the complete state of the universe at that instant. One of the most philosophically troubling implications of relativity is the nature of the present moment. In everyday life, we think of now as a universal instant that spans the entire universe. At this moment, there are facts about what's happening everywhere, what's occurring on Mars, in the Andromeda Galaxy, at the edge of the observable universe. We imagine that existence proceeds through a sequence of universal nows, each one containing the complete state of the universe at that instant. But relativity says this is wrong. There is no universal now. The present moment is not a cosmic fact but an observer-dependent phenomenon that depends on your state of motion and your location in a gravitational field. To understand this, we need to explore the relativity of simultaneity in detail. Consider two events. Event A happens on Earth, and Event B happens on Alpha Centauri, for light years away. If you're sitting still on Earth when event A occurs, you might consider event B to be happening now as well, simultaneously with event A. But someone moving past you at high velocity would disagree. Due to the relativity of simultaneity, they would observe event B occurring at a different time relative to event A. If they're moving toward Alpha Centauri, they might see event B occurring before event A. If they're moving away, they might see event B occurring after event A. The faster they move, the larger the time difference they observe. Both observations are correct. There is no absolute fact about whether events A and B are simultaneous. Simultaneity is relative to your reference frame. This means that the set of events you consider to be happening now is different from the set of events someone moving relative to you considers to be happening now. Think about what this means for the concept of the present. Your now is a slice through spacetime that includes all events at zero time distance from your current moment. But someone moving relative to you has a different slice, a different surface of simultaneity rotated in spacetime. Their now includes different distant events than yours does. The faster the relative motion, the greater the difference in simultaneity. For extreme velocities approaching light speed, the difference becomes dramatic. An event you consider to be in the distant future might be in their present. An event you consider past might be their future. Yet both perspectives are equally valid. This creates a profound problem for the common-sense notion of time. We want to say that the present moment is advancing, that future is becoming present and present is becoming past, that there's a universal now moving through reality. But if simultaneity is relative, if different observers have different nows that don't align, then this picture cannot be correct. There is no universal advancing present. There are only local presents, observer-dependent slices through spacetime that vary with motion and gravity. Some philosophers and physicists embrace this implication and adopt what's called the block universe view. In this view, all of spacetime exists as a complete four-dimensional structure, a block. Past, present, and future are all equally real, all existing within the spacetime block. The passage of time is not ontologically fundamental, but rather a feature of how conscious beings experience their journey through the block. According to block universe, when you experience the present moment, you're experiencing one location along your world line through spacetime. The past is those locations on your world line you've already traversed. The future is those locations you will traverse. But from a perspective outside time, a God's eye view of the entire spacetime block, past, present, and future all exist simultaneously. Nothing is becoming or ceasing to be. Everything just is eternally present in the block. This view explains why simultaneity is relative. Different observers moving through the block along different world lines have different surfaces of constant time. Their slices through the block are tilted relative to each other. What one observer considers a horizontal slice at constant time is a diagonal slice from another observer's perspective. Both are valid ways of slicing up the block, just as you can slice a loaf of bread straight across or at an angle, same loaf, different slices. But block universe has deeply counterintuitive implications. It suggests that future events already exist. Your future self is already real, already located somewhere in the spacetime block, already experiencing future moments. The block universe contains all of history at once. Past, present, future, all equally existent, none more real than any other. This seems to eliminate genuine change. If all moments exist eternally in the block, nothing ever becomes or ceases to be. The universe doesn't evolve. It just is. Change becomes an illusion created by consciousness moving through the block and experiencing one slice at a time. But the block itself is static, unchanging, eternal. It also seems to threaten free will. If your future actions already exist in the spacetime block, determined locations in a fixed structure, how can your choices be free? You will do what you will do, what you're already doing from the block universe perspective. The feeling of choosing seems like an illusion if the choices are already made, already real, already part of the eternal block. Not everyone accepts block universe. Some philosophers defend presentism, the view that only the present is real. According to presentism, past events have ceased to exist and future events don't yet exist. Only the present moment is real, and reality consists of this constantly changing present. Presentism aligns better with our phenomenology. It feels like only the present is real. The past is gone. The future isn't here yet. We seem to inhabit a thin slice of reality, the now that continuously becomes different as time passes. Presentism takes this appearance seriously and makes it metaphysically fundamental. But presentism faces serious challenges from relativity. If only the present is real, which present? Your present or mine? If we're moving relative to each other, we disagree about which distant events are present. Does reality depend on motion? Does what exists change based on velocity? This seems absurd. Presentists have various responses. Some argue that there is a preferred reference frame, perhaps the frame defined by the cosmic microwave background or the average rest frame of matter in the universe, and that this frame's surface of simultaneity defines the real present. But this contradicts relativity's principle that all reference frames are equally valid. It reintroduces absolute space and time, which relativity specifically denies. Other presentists embrace a more radical view. Reality is indeed observer-relative. What exists for you is different from what exists for me if we're in relative motion. There's no single objective reality, but rather multiple observer-dependent realities that overlap in some regions and diverge in others. This preserves presentism, but at the cost of abandoning a single shared reality. A middle position is sometimes called growing block universe. This view says that past and present are real. They exist in the spacetime block, but future is not yet real. The block grows as time passes, with the present moment being the growing edge of reality. Future events don't yet exist. They come into being as the block extends. Growing block preserves the intuition that the future is open while accepting that the past is fixed. It gives time a real direction. Past to future is the direction of increasing reality. And it can accommodate relativity by saying that the growing edge, the present, is observer-relative. Different observers have different surfaces where reality is currently growing. But growing block faces its own problems. What does it mean for the block to grow? Growing implies changing over time. But time is already part of the space-time structure. For the block to grow over time would require a metatime outside space-time, which seems incoherent. If space-time already contains all temporal relations, there's no external time available for the space-time structure itself to change with respect to. These debates are ongoing. Philosophers of physics disagree about what relativity implies for the metaphysics of time. What's clear is that relativity has made time much more mysterious than pre-relativistic physics suggested. The simple picture of universal time, a single timeline everyone shares with past fixed and future open, cannot be maintained in light of relativity. But what replaces it is unclear and contentious. There's also the question of consciousness and its relationship to time. Our experience of time has particular phenomenological features that seem hard to reconcile with the physics of spacetime. We experience time as flowing. The present feels like it's moving forward, carrying us from past into future. We remember the past but don't experience it now. We anticipate the future but can't access it yet. The present feels special, immediate, the locus of our existence. This phenomenology is undeniable. It's how time feels from the inside. But nothing in relativity requires or explains this flow. Spacetime is a four-dimensional structure. Your world line exists within it as a complete path from birth to death. From the block universe perspective, all moments on your world line are equally real. Your past self experiencing yesterday and your future self experiencing tomorrow are both just different locations on your world line, both equally existent in spacetime. So why does one moment, the present, feel special? Why do we experience time as flowing when physics describes a static spacetime block? This is sometimes called the flow of time problem or the passage of time problem. One response is that the experience of flow is generated by consciousness. Your brain constructs the feeling that time passes by processing temporal information in particular ways. Memory creates the sense of a past that no longer exists. Anticipation creates the sense of a future not yet here. Present perception feels immediate and real. These cognitive mechanisms generate the phenomenology of temporal flow even though the underlying reality is a static spacetime block. This would make temporal flow a feature of experience rather than physics. Just as colors are features of perception rather than intrinsic properties of electromagnetic radiation, temporal flow would be a feature of how consciousness processes time rather than a feature of time itself. This preserves block universe while explaining why time feels like it flows. But this raises new questions. If temporal flow is generated by consciousness, does it exist at all? Is it an illusion? Or is it real but subjective, a genuine feature of conscious experience even if not a feature of physics? And there's a deeper puzzle. Your experience of the present is presumably correlated with brain states. Your brain right now is in a certain state that corresponds to experiencing this present moment. But in block universe, that brain state exists eternally at this location in spacetime. It's always experiencing this present moment from the block perspective. So how does the present move? How do you experience a sequence of present moments if each brain state is eternally experiencing its corresponding moment? One answer is that the sequence is encoded in memory. Each moment's brain state includes memories of previous moments, creating the impression of having moved through time even though from the block perspective, each moment exists statically with its memories intact. The present moves because later moments include memories of earlier moments, creating temporal structure within the block. But this still doesn't explain why you experience yourself as being at one particular moment rather than all moments simultaneously. In block universe, all moments of your life exist. Why is your consciousness located at this particular moment right now? Why do you experience a thin slice of your world line rather than the entire thing at once? This is the problem of the now in philosophy of time, and it's unsolved. We don't have a fully satisfactory explanation for why consciousness experiences a moving present if physics describes a static block. This suggests either that our understanding of consciousness is incomplete, or that our interpretation of relativity is missing something, or that the relationship between mind and physical reality is more subtle than we recognize. Time dilation also creates puzzles about personal identity. Consider the twin paradox again, but focus on identity rather than aging. The twins start identical, same age, same memories, same biological state. They separate. One travels at high speed, experiencing less time. They reunite. Now they're different ages with different amounts of memory and experience. In what sense are they still the same people? The traveling twin has the same body they started with, aged normally from their perspective. But they've experienced far less time than their stay-at-home twin. Fewer thoughts have occurred. Fewer memories have formed. Less psychological development has happened. If personal identity depends on psychological continuity, the connection between mental states over time, then the traveling twin has less continuity with their past self than the stay-at-home twin does, because less time has elapsed for them. If identity depends on amount of conscious experience, the traveling twin has had less experience, so in some sense they're less progressed in identity development. But from the traveling twin's perspective, they aged normally. They had a continuous stream of conscious experience from departure to return, with normal causation linking each moment to the next. Their identity feels just as continuous as their twins, even though objectively less time elapsed. This shows that personal identity has both objective and subjective aspects that can come apart with time dilation. Objectively, the twins have experienced different amounts of time. Subjectively, both experienced normal, continuous identity development. Which matters more for identity? The puzzle becomes even more extreme with larger time differences. Imagine you travel at near light speed and return 1 year older while Earth has aged 1,000 years. Are you still the same person? You have psychological continuity with your past self, continuous memories, continuous experience, normal aging from your perspective. But you're now a living fossil, displaced from your time. Everyone you knew long dead, civilization transformed beyond recognition. Your biological age is what it was plus 1 year. But your historical age, how far into the future you exist, is 1,000 years greater. You're both a young person, biologically, and an ancient relic, historically. Your identity spans an enormous temporal distance even though you've only aged slightly. In what sense are you the same person who left Earth 1,000 years ago, from Earth's perspective? There's also the question of identity persistence through time given relativity of simultaneity. Consider yourself right now and yourself 1 hour from now. In everyday thinking, there's a clear temporal order. Now comes before 1 hour from now. Your present self exists, your future self doesn't yet exist but will exist. But for someone moving at high velocity relative to you, their surface of simultaneity might include your 1 hour future self as present from their perspective. From their frame, your future self already exists simultaneously with their current moment. Does this mean your future self already exists? Or exists for some observers but not others? What does it mean for your identity to persist through time if different observers disagree about which version of you currently exists? Block Universe offers an answer. All versions of you exist in spacetime. Your world line is a four-dimensional worm, extending from birth to death, and every moment on that worm is equally real. Personal identity is the continuous path through spacetime, not a special entity persisting through time. You are your world line, and all of it exists eternally in the block. But this makes personal identity strange. You are not a three-dimensional being that endures through time, but rather a four-dimensional being extended through spacetime. Your past and future selves are as real as your present self. They're just at different temporal locations along your world line. You don't change from past to future. You just have different properties at different spacetime locations. Change becomes like spatial variation. You're different at different places, but all places exist simultaneously in space. Similarly, you're different at different times, but all times exist simultaneously in spacetime. This four-dimensional conception of personal identity is hard to reconcile with our felt experience of being a three-dimensional being that changes through time. We feel like we're located at the present and moving into the future, not like we're extended across time with past and future selves equally existent. The block universe view might be physically accurate, but it's psychologically alien. Another philosophical puzzle is the arrow of time. Why does time have a direction? Why can we remember the past but not the future? Why do causes precede effects rather than the reverse? Why does entropy increase rather than decrease? These are different manifestations of temporal asymmetry. Time's past-future direction is physically and experientially meaningful in a way that space's left-right direction is not. Relativity doesn't fully explain the arrow of time. Relativistic physics is mostly time-symmetric. The equations work equally well running forward or backward in time. If you take a valid solution to Einstein's equations and reverse the time direction, you get another valid solution. This suggests that fundamentally, physics doesn't prefer past to future over future to past. Yet clearly time does have an arrow. We experience it directly. We never see broken eggs spontaneously reassembling. We never see smoke converging back into a chimney. We never see memories form of future events. The past-future asymmetry is so obvious that it seems strange to question it. The standard explanation involves entropy and the second law of thermodynamics. Entropy, roughly disorder or randomness, increases over time in isolated systems. This is a statistical law. High entropy states are vastly more probable than low entropy states, so systems tend to evolve from low to high entropy. The arrow of time is the direction of entropy increase. But this raises the question, why was entropy low in the past? If entropy naturally increases, and the universe is very old, why isn't entropy already at maximum? Why do we find ourselves in a relatively low entropy state with an entropy gradient pointing toward the past? The answer seems to involve initial conditions. The universe started in an extraordinarily low entropy state at the Big Bang, everything compressed, ordered, far from thermal equilibrium. Since then, entropy has been increasing as the universe expands and systems become more disordered. We live in the middle of this entropy increase, with lower entropy in our past, toward the Big Bang, and higher entropy in our future, toward heat death. The arrow of time, then, is not fundamental to physics but rather a consequence of initial conditions. If the universe had started in high entropy, there would be no arrow, or rather, time would be symmetric with entropy fluctuating randomly. The fact that the universe started ordered and is becoming disordered creates the arrow we experience. But why did the universe start in low entropy? This is an unsolved problem in cosmology. Some theories propose that the Big Bang was actually a low-entropy fluctuation in an eternally existing high-entropy state. Others suggest that the Big Bang was the beginning of time itself, and asking what came before is meaningless. Still others propose multiverse scenarios where our universe's low initial entropy is a selection effect. We can only exist in universes with low initial entropy because life requires entropy gradients. Whatever the answer, the arrow of time appears to be about thermodynamics and cosmology rather than relativity. Relativity tells us that time is relative and can dilate, but it doesn't explain why time has a direction. The direction comes from entropy, and entropy's direction comes from initial conditions. This separates the metaphysics of time, what time is fundamentally, from the arrow of time, why time has a direction. Relativity addresses the former but not the latter. The block universe view of spacetime, combined with time's relativity, creates the sharpest version yet of the free will versus determinism problem. If all of spacetime exists at once as a four-dimensional structure, and your entire world line exists within that structure, then in some sense your future actions already exist. They're already real, already part of the spacetime block, already determined locations in four-dimensional space. Does this mean your actions are not free? If your future self already exists, making certain choices and taking certain actions, can those choices be genuinely free? Or are they fixed, inevitable features of the spacetime block that were always going to occur? This depends on what you mean by free will. If free will requires that the future is genuinely open, that multiple futures are possible until you choose, then block universe seems to eliminate free will. There's only one future, the one that exists in the spacetime block. Alternative possibilities don't exist. Your future is determined by the structure of spacetime. But if free will only requires that your choices flow from your own desires, beliefs, and reasoning, that they're caused by your mental states rather than imposed from outside, then block universe might be compatible with free will. Your choices can be determined by your psychology even if they're also determined by the spacetime structure. What matters is the source of the determination, not whether determination exists. This is the compatibilist position. Free will is compatible with determinism. You can be free even if your actions are determined, as long as the determination comes from your own mental states rather than external coercion. From this perspective, block universe doesn't threaten free will because your future actions, though already existing in spacetime, are still caused by your decision-making processes. The causal chain runs through your consciousness, making the choices genuinely yours. The incompatibilist responds that this isn't real freedom. If your future actions are already determined, already real in the space-time block, then you can't do otherwise. There's only one possible future, and your so-called choices are just predetermined steps along your fixed world line. Real freedom would require the ability to make choices that genuinely alter the future, creating new possibilities. But if the future already exists, no new possibilities can be created. There's no consensus on this debate. It's been ongoing for centuries, and relativity adds new complications without resolving anything. What's clear is that if you take block universe seriously, the future exists just as much as the past and present. This makes the future seem fixed, which threatens ordinary conceptions of free will. Whether freedom can survive this fixedness depends on what freedom means, and philosophers disagree about that fundamentally. Interestingly, relativity's time dilation creates a practical asymmetry even in block universe. From your perspective, your future is unknown and feels open. You experience yourself as making choices that shape what happens next. This phenomenology persists even if, from a block universe perspective, your choices are already made and your future is already real. The experiential openness of the future is preserved even if the metaphysical openness is eliminated. Perhaps this is enough. Perhaps what matters for practical purposes is that the future feels open, that you experience yourself as making meaningful choices, that deliberation and decision-making feel real and consequential. The metaphysical status of the future, whether it exists in some timeless sense, might be irrelevant to the pragmatics of living and choosing. This view suggests that grief at loss involves a confusion about time. When someone dies, they don't cease to exist in an absolute sense. Their world line ends, but the world line itself, the complete four-dimensional structure of their existence, remains eternally real in space-time. They exist at all the space-time locations they occupied during life. They're just not located at your current temporal position anymore, analogous to how they might not be at your current spatial position if they moved away. Does this provide comfort? For some, yes. The deceased hasn't vanished from reality but merely from your present. They remain real at their temporal locations, existing permanently in the space-time block. For others, this is cold comfort. What matters is not metaphysical existence but lived experience, and the dead are no longer experiencing. Their world line is complete, unchanging, past from your perspective even if eternal from the block perspective. These different reactions show how worldview affects meaning. If you think of the present as the only real moment and the future as genuinely open, then your choices feel consequential because they determine what becomes real. You're creating reality through your actions. But if you adopt block universe, all moments are equally real and your choices don't create anything. They're just part of the eternal structure. This can feel either liberating, nothing is lost, everything is eternal, or despairing, nothing matters, everything is fixed. Probably the most reasonable stance is that meaning is primarily about experience rather than metaphysics. What matters is that life feels meaningful, that choices feel important, that relationships feel valuable, that experiences feel significant. Whether the metaphysical status of future moments is already real or not yet real is less important than whether your current experience is rich, engaging, and worthwhile. Time's relativity doesn't change the phenomenology of lived experience. Your life still feels like a journey from birth toward death, with meaningful choices along the way. Even if a physicist describes this as a static world line in spacetime, you experience it as dynamic, flowing, unfolding. And perhaps the experiential reality is what matters most. After all, you are not a physicist theorizing about spacetime from outside. You are a conscious being embedded within spacetime, experiencing one moment after another, navigating through your world line with limited knowledge of what comes next. From this embedded perspective, the future is unknown, choices are open, actions have consequences. This perspective is inescapable. You can't view your own life from the block universe perspective because you're inside time, not outside it. So perhaps the right response to relativity's implications for meaning is pragmatic acceptance. Yes, time is relative. Yes, block universe might be correct. Yes, your future might already exist in space-time. But none of this changes how you should live. You should still make choices carefully, treat others well, pursue meaningful goals, cherish relationships. The metaphysics of time is separate from the ethics of living. Time dilation and relativity also shed interesting light on the experience of aging. Everyone ages at the rate proper time accumulates along their world line. But proper time accumulation can vary depending on velocity and gravity, meaning different people can age at genuinely different rates. We've discussed the twin paradox, where one twin ages less due to high-velocity travel. But even in everyday life, people age at slightly different rates based on their lifestyles. Someone who frequently flies at high altitudes ages microseconds faster per year than someone who stays at sea level. Someone who drives fast regularly ages nanoseconds slower than someone who walks everywhere. These differences are negligible practically, far too small to notice. But they're real. Time genuinely passes at different rates for different people based on their motion and gravitational environment. Everyone's proper time is their own, accumulating at a rate determined by their specific path through spacetime. This makes aging deeply personal in a physical sense. You don't just feel like you're aging at your own rate, you literally are. Your biological clock runs at the rate your proper time accumulates. Someone else's biological clock runs at their proper time rate. If your world lines differ significantly in velocity or gravitational environment, you accumulate proper time at different rates and thus age differently. But again, from your perspective, aging feels normal. You don't feel like you're aging slowly or quickly. You just age. Cells divide, proteins degrade, tissues wear out, all at the rates these processes naturally proceed in your reference frame. The rate feels constant because you're measuring with your own time, which always flows at 1 second per second from your perspective. This relates to why time seems to speed up as you age. When you're young, each year represents a large fraction of your total life. At age 10, 1 year is 10% of your life. At age 50, 1 year is only 2%. Psychological time, the sense of how long periods feel, is influenced by this proportional difference. Years feel shorter as you age because they're smaller fractions of your accumulated experience. But this is psychological, not physical. Your proper time continues accumulating at the same rate throughout your life. 1 year of proper time at age 50 is the same duration as 1 year at age 10 measured physically. The difference is in memory, attention, novelty, and proportion, psychological factors affecting time perception, not physical time dilation. Still, there's an interesting parallel. Just as time dilation makes time pass at different rates for different observers, psychological factors make time feel like it passes at different rates at different life stages. Both are real effects, one physical, one psychological, that create variations in temporal experience. And both are imperceptible from within because you're always experiencing your own time at what feels like normal rate. Relativity's implications extend to death and mortality. If block universe is correct, death is not annihilation but rather the terminal point of your world line. Your existence doesn't end. It's just bounded. You exist from birth to death along your world line, and that complete structure exists eternally in spacetime. This reframes death. Instead of ceasing to exist at death, you simply don't extend beyond death. Your world line has a definite endpoint, just as it has a definite starting point. But the world line itself, everything you ever were, experienced, thought, felt, remains real within spacetime. You exist as a four-dimensional object with temporal boundaries, not as a three-dimensional object that disappears at death. Does this make death less tragic? Perhaps in one sense. If you continue to exist eternally in space-time at all the moments you lived, death is not total erasure. But in another sense, death remains tragic because it means the end of new experiences, the cessation of consciousness, the termination of your ability to interact with the world. Your world line is complete and unchanging. No new moments will be added. From the block universe perspective, death has already happened. Your death exists at a specific space-time location, your world line's endpoint. From outside time, looking at the complete space-time structure, your birth and death are both present. They're just at different temporal coordinates. Neither is more real than the other. They're both fixed points bounding your existence. But from your embedded perspective within time, death is always in the future until it isn't. You're moving toward it along your world line, accumulating proper time, approaching the endpoint. This makes death feel dynamic and uncertain from inside time, even though it's static and definite from the block perspective. Relativity doesn't answer whether consciousness survives death. That's not a physics question, but a metaphysical one. What relativity suggests is that your physical existence, your world line through space-time, is permanent even though bounded. Whether this world line includes some form of continued consciousness beyond its physical endpoint is not addressed by relativistic physics. But the permanence of the world line might offer some comfort. You don't vanish from reality at death. You remain real at all the space-time locations you occupied during life. Every moment you lived, every experience you had, every thought and feeling and action, all permanently existing in the space-time structure. Death ends the extension of your world line but doesn't erase what already exists. This connects to ancient philosophical ideas about eternal recurrence or the timelessness of truth. If all moments exist eternally in space-time, then in some sense, you're always living every moment of your life from the block perspective. Your childhood and old age, your joys and sorrows, your beginning and end, all eternally present at their respective space-time coordinates. Time's passage is how you experience this eternal structure, moving through it moment by moment. But the structure itself is timeless. Whether this is actually comforting depends on individual temperament and values. Some find eternal existence in space-time reassuring. Others find it irrelevant. They care about ongoing experience, not metaphysical existence. Still others find it troubling, suggesting that even suffering and death are eternally real rather than truly past. But regardless of how you feel about it, this is what relativity suggests about time's nature. And it's worth contemplating as you consider your own mortality. You are a world line through space-time. That world line has a beginning and will have an end. But within those boundaries, you exist completely and permanently in the four-dimensional structure of reality. This is what it means to be a temporal being in a relativistic universe. So how do you integrate all of this: time's relativity, its observer dependence, its variations based on motion and gravity, the block universe implications, the disconnect between physics and experience, into a coherent understanding that can guide how you actually live? Perhaps the answer is to hold multiple perspectives simultaneously without demanding they perfectly unify. From the physicist's perspective, time is a dimension of space-time, relative and variable, described by mathematical structures. From your embedded perspective, time is experienced duration, flowing from past through present into future. Both are valid. Both describe real aspects of reality. They don't contradict each other so much as address different questions from different viewpoints. You can accept that time is relative while experiencing it as absolute. You can acknowledge that simultaneity is observer-dependent while treating your present as definite. You can recognize that the future might already exist in some sense while navigating toward it as if it's open. These aren't contradictions but complementary descriptions: physics and phenomenology, third person and first person, objective structure and subjective experience. Living with relative time means accepting this complexity. Reality is not simple. Time is not simple. The relationship between physical time and experience time is not simple. You can't reduce everything to a single coherent story that satisfies both physics and intuition. You have to hold the tension between scientific understanding and lived experience. But this tension is productive. It prevents you from being dogmatic in either direction. You don't dismiss physics because it contradicts intuition. You don't dismiss experience because it doesn't match mathematical description. You give both their due, recognizing that complete reality requires both perspectives even though they don't perfectly align. This is ultimately a mature relationship with knowledge. You understand what science says about time without pretending it captures everything important about temporal experience. You honor your experience of time without pretending it reveals time's fundamental nature. You live in the space between objective understanding and subjective awareness, drawing on both as appropriate. And in practical terms, this means take care of your proper time. It's the only time you actually experience. Respect others' different temporal experiences. Their time is as real as yours, even if different. Stay present to your current moment. It's your actual temporal location. Accept temporal limits. Finite time is what makes time meaningful. Make peace with mortality. Your world line is bounded but real. And don't demand that time be other than it is. Relative, variable, local, strange. This is living with relative time. Not perfectly understanding it. That's impossible from within. Not ignoring it. It's too fundamental to dismiss. But accepting it as the medium of your existence, strange and familiar simultaneously, the dimension in which you live your life whether you fully comprehend it or not. In the end, whether time is absolute or relative, whether the future exists or not, whether your choices are free or determined, you still face the same question. How should you live? And the answer to that question doesn't depend on space-time structure. It depends on what you value, what matters to you, what you care about. Time's nature is fascinating to understand, but it doesn't override the immediate reality of conscious experience and the values that arise from it. From your perspective on the surface, time would feel normal. Seconds would feel like seconds. But if you looked up at someone in orbit far from the star, you'd see them moving in fast motion. Their clocks would tick quickly. They'd age rapidly from your perspective. Meanwhile, they'd look down and see you in slow motion. Your movements sluggish, your clocks ticking slowly, time stretched out relative to theirs. If you stayed on the surface for what felt like 1 year to you, about 1.2 years would pass for the orbital observer. If you had a twin in orbit, you'd be slightly younger when you climbed back up to meet them. Not dramatically younger. This isn't as extreme as traveling near light speed, but measurably younger. And again, you wouldn't feel the time dilation. Your year on the surface would feel exactly like a year. Normal duration, normal experience, normal aging. The difference would only appear when clocks were compared. The ultimate extreme is a black hole. Near a black hole's event horizon, time dilation approaches infinity relative to distant observers. If you were to fall toward a black hole and someone watched from far away with a powerful telescope, they'd see you slow down as you approach the horizon. Your descent would appear to take longer and longer. You'd get closer and closer to the horizon but never quite seem to cross it. Your image would freeze at the horizon, redshifted and dimmed, but never disappearing. From your perspective, the experience would be completely different. You'd fall smoothly across the horizon in a finite time. For a large black hole, say one with 1 million solar masses, you might cross the horizon in seconds without feeling anything unusual. Space would feel normal. Time would feel normal. The only hint that something strange was happening would be looking back at the universe you're leaving, which would appear to speed up and blue shifted as you fell. After crossing the horizon, you'd continue falling toward the central singularity. Depending on the black hole size, you might have seconds or minutes before reaching the singularity and experiencing infinite tidal forces. Throughout the fall, time would continue to feel normal to you. You wouldn't experience any slowing or stretching of duration. But to a distant observer, you never fell in. You froze at the horizon. Infinite time would pass in the external universe while you experienced finite seconds falling inward. The distant observer and you would have incompatible descriptions of the same event, both valid in their respective frames. This creates a puzzle about information. You and everything you carry fall into the black hole from your perspective. But from the external perspective, you never cross the horizon. The information you carry should remain on the horizon, encoded in some way. This is related to the black hole information paradox, one of the deepest unsolved problems in theoretical physics. But for our purposes, what matters is the phenomenology. Even in the most extreme time dilation imaginable, falling into a black hole where external time approaches infinity, your subjective experience remains normal. Time feels like time. Duration feels like duration. You cannot perceive the dilation directly because you are embedded within it. One of the most philosophically troubling implications of relativity is that there is no universal now. The present moment is not a cosmic fact, but rather an observer-dependent phenomenon. Different observers moving at different velocities will have different surfaces of simultaneity, different sets of distant events that they consider to be happening now. This undermines a basic intuition about time. We naturally think of the present as a singular, universal moment that sweeps through reality, turning future into past. At any given instant, there's a fact about what's happening everywhere in the universe simultaneously. Or so we think. But relativity says no. Simultaneity is relative. If you're sitting still and I'm moving past you at high velocity, we disagree about which distant events are happening now. An event that you consider to be in the present might be in my past or future. There's no absolute fact about whether we're right or wrong. Both perspectives are equally valid. Let's make this concrete with a specific example. Imagine two space stations, Station A and Station B, separated by 10 light-years. They're both at rest relative to each other and relative to the cosmic microwave background, so they share a common reference frame. In this frame, there's a clear notion of simultaneity. If Station A experiences an event at noon on January 1st, 3000, Station B also experiences now at noon on January 1st, 3000. These events are simultaneous in their shared frame. Now imagine a spacecraft traveling from Station A toward Station B at 80% light speed. The spacecraft passes Station A exactly at noon on January 1st, 3000 in the station's reference frame. At this moment, what does the spacecraft consider to be happening now at Station B? Due to the relativity of simultaneity, the spacecraft's now slice through spacetime is tilted relative to the station's slice. The spacecraft considers events at Station B that occur several years in the future, from the station's perspective, to be happening simultaneously with the spacecraft passing Station A. From the spacecraft's perspective, Station B is already several years ahead in time. This isn't an illusion or measurement error. It's a genuine fact about spacetime geometry. The spacecraft and the stations disagree about which events are simultaneous, and there's no absolute answer to who's correct. Both are correct in their respective reference frames. Now consider a second spacecraft traveling from Station B toward Station A at 80% light speed, passing Station B at the same moment, in the station's frame, that the first spacecraft passes Station A. This second spacecraft's now slice is tilted in the opposite direction. From its perspective, Station A is several years in the past relative to Station B. So we have three different notions of now. The stations say A and B are simultaneous. Spacecraft 1 says B is years ahead of A. Spacecraft 2 says A is years behind B. All three are correct. There's no absolute present moment linking the stations. The present is relative to your reference frame, and different reference frames have different presents. This creates deep philosophical puzzles. If the present is relative, what does it mean to say something exists now? Existence seems tied to presence, to actuality, to reality. But if different observers have different presence, do they have different realities? Does an event exist for one observer but not yet exist for another? One response is the block universe view I mentioned earlier. All of spacetime exists at once as a four-dimensional structure. Past, present, and future are all equally real. Our experience of time as flowing through these regions is an artifact of consciousness, not a feature of reality itself. From God's eye view outside spacetime, there is no flow, no becoming, no present moment moving through time. There's just the static four-dimensional block containing all events that ever happen. This view solves the problem of relative simultaneity. If all events exist equally, it doesn't matter that different observers disagree about which events are present. The present is just where you are in space-time, and different observers are at different locations, so naturally they experience different presence. But all the events exist regardless of anyone's present. So we have three different notions of now. The stations say A and B are simultaneous. Spacecraft 1 says B is years ahead of A. Spacecraft 2 says A is years behind B. All three are correct. There's no absolute present moment linking the stations. The present is relative to your reference frame, and different reference frames have different presence. This creates deep philosophical puzzles. If the present is relative, what does it mean to say something exists now? Existence seems tied to presence, to actuality, to reality. But if different observers have different presence, do they have different realities? Does an event exist for one observer but not yet exist for another? One response is the block universe view I mentioned earlier. All of spacetime exists at once as a four-dimensional structure. Past, present, and future are all equally real. Our experience of time as flowing through these regions is an artifact of consciousness, not a feature of reality itself. From God's eye view outside spacetime, there is no flow, no becoming, no present moment moving through time. There's just the static four-dimensional block containing all events that ever happen. This view solves the problem of relative simultaneity. If all events exist equally, it doesn't matter that different observers disagree about which events are present. The present is just where you are in space-time, and different observers are at different locations, so naturally they experience different presence. But all the events exist regardless of anyone's present. But this creates its own problems. If the future already exists, is it fixed? Do our choices matter if future events are already real? Where does free will fit if tomorrow is as real as today, just at a different spacetime location? Another response is presentism, the view that only the present exists, the past is gone, and the future isn't yet real. But presentism has trouble with relativity. If only the present exists and the present is relative, then what exists depends on your reference frame. An event might exist for one observer because it's in their present, but not for another because it's in their past or future. This makes existence relative, which seems absurd. Surely whether something exists shouldn't depend on how fast you're moving. A third response is the growing block view. The past and present exist, but the future doesn't yet. Reality is constantly growing as time advances, adding new layers of present becoming past. But this also has problems with relativity because it requires a preferred notion of simultaneity to define which events are being added to reality now. And relativity says there's no preferred simultaneity. None of these views is clearly correct. Philosophers and physicists continue to debate how to interpret relativity's implications for the nature of time. What's indisputable is that time is stranger than pre-relativistic thinking imagined. The present is not universal. Simultaneity is relative, and our intuitions about time structure need revision. Time dilation also creates puzzles about personal identity. Personal identity over time is philosophically puzzling even without relativity. What makes you the same person today as you were yesterday? Your body has changed, cells have died and been replaced. Your mind has changed, you have new memories, beliefs, desires. Yet you consider yourself the same person. What grounds this identity? Traditional answers include psychological continuity. You have memories connecting past and present, and physical continuity. Your body persists through time despite cellular replacement. These accounts assume that time flows uniformly, that you and others age at the same rate, that comparing ages is straightforward. But time dilation complicates this. If you travel at high speed while your twin remains stationary, you age less. When you reunite, you're biologically younger despite being the same chronological age at birth. You've experienced less time. Fewer thoughts have occurred. Fewer memories have formed. Less psychological change has happened. Are you still the same age as your twin? In one sense, yes, you were born on the same day, so you're the same calendar age. In another sense, no, you've lived through less proper time, so you're biologically younger. Which notion of age matters for personal identity? Consider a more extreme case. You leave Earth at 20 years old, travel at 99.99% light speed for what feels to you like 30 years, and return at age 50, from your perspective. But Earth has aged 3,000 years. Your children are long dead. Your civilization is transformed beyond recognition. You return to a world where no one knows you, where your entire context has vanished. In what sense are you still the same person who left? Psychologically, you have continuity, memories connecting your departure to your return. Physically, you have continuity, your body persists despite cellular changes. But contextually, you're severed from your time. You're a displaced person, belonging to an era 3,000 years in your past. Personal identity seems to require not just internal continuity but external context. You're defined partly by your relationships, your culture, your historical moment. Time dilation can preserve internal continuity while destroying external context. You remain you, but your you-ness was partly constituted by relationships and contexts that no longer exist. This suggests that personal identity has a temporal aspect that relativity makes problematic. You're not just a person, you're a person in a particular time. And if time is relative, if you can experience different amounts of it than others, then your temporal location becomes ambiguous. You're 50 years old internally but 3,020 years old externally. Which temporal identity is more fundamental? Perhaps personal identity should be understood in terms of proper time rather than coordinate time. You're as old as you've experienced yourself to be, regardless of external calendars. Your age is defined by your accumulated experiences, thoughts, and biological changes, all measured in your reference frame. This preserves a clear notion of identity even with time dilation. But this makes age relative. You and your twin might disagree about how old you are relative to some external event. There's no absolute fact about whether you're older or younger than that event because simultaneity is relative. Your age is well defined in your frame, but comparing it to ages in other frames requires specifying a synchronization convention. These puzzles don't have definitive solutions. They reveal that personal identity over time is more complex than it initially appears. And relativity makes it even more complex by allowing different amounts of time to pass for different people between the same events. Identity persists, but its temporal aspects become relative and frame-dependent. There's a deeper question about why time feels the way it does. Why does duration have the qualitative character it has? Why does waiting feel like waiting? Why does time seem to pass at the rate it does? And why is this rate so stable? Why doesn't time speed up or slow down from your perspective? Part of the answer comes from neuroscience. Your sense of time passing is constructed by your brain from various neural processes. There's no single clock in the brain, but rather multiple timing mechanisms operating at different scales. For short durations, milliseconds to seconds, timing might involve neural oscillators or the sequential firing of neuron populations. For longer durations, seconds to minutes, timing might involve working memory and attention. For very long durations, hours to days, timing might involve circadian rhythms and memory consolidation. All of these mechanisms are physical processes with specific rates. When your brain runs faster, when neurons fire more frequently, when neurotransmitters are released more often, when oscillations cycle more rapidly, you perceive time as passing more slowly. This is why time seems to slow down in emergencies or on intense drugs. Your brain is processing faster, packing more cognitive events into each second of external time, so each second feels longer. Conversely, when your brain runs slower, when neurons fire less frequently, when processing is reduced, you perceive time as passing faster. This is why time flies when you're engaged in flow states or why hours can vanish during sleep. Fewer cognitive events occur per second of external time, so time seems compressed. But this is still time relative to your internal processing rate. What relativity reveals is that your internal processing rate itself can run at different speeds relative to external clocks depending on your motion and gravitational environment. When you're in a time-dilated reference frame, your neurons literally fire slower, measured against external clocks. Your neurotransmitters are released at longer intervals, your neural oscillation cycle at reduced frequencies. But you can't detect this because your brain's timing mechanisms are also slowed proportionally. Your perception of time depends on ratios of different timing processes. You judge duration by comparing how many heartbeats occurred versus how many thoughts you had, or how many neural cycles completed versus how much external change you observed. All these ratios remain constant even when all the processes slow down together. It's like trying to measure the speed of a conveyor belt using a clock that's also on the conveyor belt. Both the belt and the clock might speed up or slow down, but if they change together, you measure the same belt speed because you're using a changed clock to measure a changed belt. The ratio stays constant even though the absolute rates change. This explains why time always feels like it passes at one rate. Now feels like it takes 1 second to pass, despite time actually running at different rates in different reference frames. Your perception of time's passage rate is measuring ratios of internal processes. And these ratios are preserved even when all processes dilate together. There's a deeper mystery here about consciousness and time. Why do we experience time as flowing? Why does it feel like there's a moving present moment that advances from past to future? Physics doesn't require this flow. The equations of physics work equally well with time flowing forward or backward, and special relativity treats time as a dimension similar to space, though with different mathematical properties. Yet consciousness seems to have an intrinsic temporal direction. You experience memory pointing to the past and anticipation pointing to the future. You feel yourself moving through time from earlier to later. The present seems to advance, carrying you with it from what has been toward what will be. This felt flow of time is sometimes called the A series of time, terms like past, present, future, as opposed to the B series, terms like earlier, later, simultaneous. Physics describes time using the B series. Events have temporal relations to each other, earlier/later, but there's no privileged present moment. Consciousness experiences time using the A series. There's definitely a present moment now, and it's definitely advancing. Why this discrepancy? Perhaps consciousness requires temporal flow. Perhaps being conscious just is experiencing time as flowing, having a perspective from within time rather than outside it. If so, the phenomenology of temporal flow is essential to consciousness even if it doesn't correspond to anything fundamental in physics. Or perhaps the flow is an illusion created by memory and anticipation. You remember past moments and anticipate future moments, and this creates the sense of a present moving from remembered past toward anticipated future. But the flow itself might not be real. There's just a sequence of conscious states, each of which includes memories, giving a sense of past, and expectations, giving a sense of future, creating the experience of flow without actual flow occurring. These are open questions in philosophy of mind and time. What's clear is that the subjective experience of time, including the sense of flow, the feeling of duration, the perception of temporal passage rate, is a complex construction that depends on internal neural processes. And relativity shows that these internal processes can run at different rates relative to external time without the experiencer detecting any change in how time feels. The feeling is always the same, now feels like now, seconds feel like seconds, even when the physical reality is quite different. The block universe view of spacetime raises questions about free will. If all of spacetime exists at once, with future events already real in some sense, does this mean the future is determined? If your future self already exists in the block universe, making decisions and taking actions, were those decisions free? Or were they inevitable, fixed features of the spacetime block? This is a version of the classic free will versus determinism debate, but with a relativistic twist. In non-relativistic physics, you could maintain that the present is real, the past is fixed, and the future is open, not yet determined. But relativity makes this harder because it blurs the distinction between past, present, and future. If simultaneity is relative, where does the present end and the future begin? One response is to deny that the block universe implies determinism. Just because all events exist in spacetime doesn't mean they're causally determined by prior events. Your future decisions could still be free even if they already exist in some four-dimensional sense. The block universe describes what happens, but not necessarily why it happens or whether it had to happen. Another response is to embrace compatibilism, the view that free will is compatible with determinism. Your decisions can be free in the relevant sense. They're based on your desires, beliefs, and reasoning, even if they're determined by prior causes, including the laws of physics. What matters for free will is that your decisions flow from your mental states, not that they're uncaused. A third response is to reject the block universe entirely and maintain presentism. Only the present is real, the past is gone, the future isn't yet. This preserves the intuition that the future is open and undermined. But as mentioned earlier, presentism has trouble accommodating relativity's relativity of simultaneity. There's no consensus among physicists or philosophers about which response is correct. What's clear is that relativity complicates the free will debate by making it harder to draw sharp distinctions between past, present, and future. The nature of time is bound up with questions about causation, agency, and determinism in ways that remain philosophically contentious. What does it mean to live in a universe where time is relative, where there's no universal present moment, where duration depends on your motion and gravitational environment, where your experience of time, though genuine, is not absolute? For most practical purposes, it means nothing. In everyday life, relativistic effects are negligible. You and everyone you interact with are moving at similar speeds and experiencing similar gravitational fields. Time passes at essentially the same rate for everyone in your immediate environment. Relativity's weirdness only matters at extreme velocities or near extreme gravitational sources, neither of which you encounter daily. But conceptually, living with relative time means accepting certain facts about reality. First, there is no universal now. The present moment is local, not global. You have a present, but it's your present, based on your location and motion. Someone else far away has a different present. There's no absolute fact about which events throughout the universe are happening simultaneously. Second, time is not a universal flow but a local phenomenon. Time passes differently in different places and for different observers. This is not error or illusion but physical reality. Time genuinely has different rates in different regions of spacetime. Third, your experience of time, while subjective, is not arbitrary. It accurately reflects your local time frame. When time feels like it's passing normally, it is passing normally relative to your reference frame. You're not misperceiving anything. You're correctly experiencing your own time. Fourth, comparing your time to someone else's time requires careful accounting of reference frames. You can't simply ask, how much time passed, without specifying for whom. Time elapsed depends on the path taken through spacetime. Different paths accumulate different amounts of proper time. Fifth, and perhaps most philosophically significant, the universe doesn't care about your experience of time. Physical laws are written in terms of spacetime geometry, not in terms of subjective duration. Your consciousness experiences a flow of time, but this flow is not fundamental to physics. It's a feature of how conscious beings interact with spacetime, not a feature of spacetime itself. There's an interesting connection between relativity and meditative practices that focus on time perception. Many meditation traditions emphasize present moment awareness and letting go of past and future. Be here now is a common instruction. Focus on immediate experience. Release rumination about past and worry about future. Relativity provides a physics-based reason to take this seriously. The present moment is the only temporal location that's absolutely definite for you. Your past is fixed from your perspective. Your future is open, but your present is where you actually exist. It's the point in spacetime where your world line currently is. Moreover, since simultaneity is relative, your present is all you can be certain about. Distant events that you consider present might be past or future from another perspective. The only now that's unambiguously real for you is your local now, the immediate environment you're causally connected to. This doesn't mean the past and future don't exist. In the block universe view, they exist as much as the present does. But from your embedded perspective within spacetime, your present is the only temporal location you directly experience. Past is memory, future is anticipation, but present is experience. Meditation traditions have intuited this without relativity. They recognize that much suffering comes from dwelling in past or future rather than inhabiting present. And relativity adds that the present is not just psychologically but also physically special. It's the only temporal location you definitely occupy. Furthermore, meditation often involves letting go of the sense that time is passing. Advanced meditators sometimes report experiencing timelessness or the dissolution of temporal flow. This might relate to how consciousness constructs temporal experience. The feeling that time flows is generated by neural processes. If those processes can be observed and released through meditation, the sense of flow might diminish. Relativity doesn't explain this, it's a different domain, but it's interesting that both physics and contemplative practice point toward the present moment and away from absolute, universal time. Both suggest that time is more relative and less fundamental than ordinary intuition assumes. What practical wisdom can we extract from relativity about how to live? First, recognize that your experience is local and subjective. You perceive reality from a particular perspective in spacetime. This perspective is valid, but it's not absolute. Others perceive from different perspectives. There's no God's eye view that settles who's right. This suggests epistemic humility about claims to no objective reality. Second, duration is real but relative. The time you experience is genuine, not illusory. Your life has a certain length measured in your proper time. But that length is not comparable to someone else's without specifying reference frames. This suggests that comparisons across different contexts are often ambiguous. Third, there's no universal present binding everything together. Events are connected by causal relationships, not by happening at the same time. What matters is whether events can influence each other, not whether they're simultaneous. This suggests focusing on causal connections rather than temporal categories. Fourth, your experience always feels normal from within. Even if external observers see your time dilated, you don't feel it. This suggests that adaptation and normalization are fundamental features of experience. You're always calibrated to your current conditions, making those conditions feel normal. Fifth, physical reality is weirder than intuition suggests. Common sense about time comes from slow speed, weak gravity environments. These intuitions break down at extremes. This suggests that intuition is a guide but not an authority. Reality is under no obligation to match your expectations. None of these amount to life-changing revelations, but they provide a scientifically grounded perspective on time that might inform how you relate to temporal experience. Time is not what pre-relativistic thinking assumed. It's relative, local, and observer-dependent. Recognizing this doesn't change your experience. Time still feels like time, but it might change how you think about that experience and its relationship to others' experiences. As we approach sleep, it's worth considering what it means to let go of the concept of absolute time. You've lived your entire life assuming, probably unconsciously, that time is universal, that there's a single timeline everyone shares, that the present moment is the same for everyone, that clocks measure some objective temporal flow independent of who's doing the measuring. But this isn't how time works. Time is local. It varies. It depends on motion and gravity. Your time is real, but it's not universal. And paradoxically, this makes no practical difference to your experience because your experience is always calibrated to your local time. Can you hold this in awareness without feeling disoriented? Can you recognize that time is relative while still experiencing it as it feels, continuous, directional, flowing? This is similar to how you might recognize that colors are features of perception rather than intrinsic properties of objects, yet still experience colors vividly without the vividness diminishing. Letting go of absolute time means accepting that temporal judgments are frame-dependent. How much time passed? Has no answer without specifying whose time. When did that happen? Depends on your reference frame. Is this event happening now? Depends on your motion. But this doesn't make time unreal or illusory. It makes it relative, which is different. Your experience of duration is a veridical perception of your proper time. It's accurate, not mistaken. It's just not universal. Can you rest in this understanding? Time is real and relative, both simultaneously. This is how the universe actually works, verified by countless experiments. Your intuitions about absolute time are approximations that work well at everyday scales but break down at extremes. And that's okay. Intuitions can be updated. Consider your present moment. Right now, as you listen to these words or read them or think about them, this moment is absolutely definite for you. It's where you exist in space-time. It's the point on your world line that corresponds to your current experience. But someone far away has a different present. An event you consider present might be in their past or future. There's no absolute fact about which events throughout the universe are happening now. Now is local, not global. Does this diminish the reality of your present? No. Your present is as real as anything can be. It's immediate, undeniable, the raw fact of your current existence. The relativity of simultaneity just means that this immediate reality doesn't extend universally. It's bounded by your causal horizon, the region of spacetime you can influence or be influenced by at this moment. And that's fine. You don't need a universal present to exist. You just need your local present, which you have. Your consciousness is anchored to this moment in space-time, experiencing this duration, this now. And that now is sufficient. Perhaps this is even liberating. You're not responsible for some universal now. You're only responsible for your local experience. Your present moment is your domain. Others have their own present moments, their own nows, which may not align with yours due to motion or gravity or distance. But that doesn't create conflict because their nows are equally valid. In this way, Relativity implies a kind of temporal tolerance. There's no single correct perspective on when things happen. Different observers have different but equally valid temporal orderings of distant events. No one is right or wrong. They're just different. Buddhism teaches impermanence as a fundamental characteristic of existence. All things arise and pass away. Nothing lasts. Clinging to permanence creates suffering. Accepting impermanence brings peace. Relativity offers a physics-based perspective on impermanence. Events are points in spacetime. They occur and then they're in the past. The present moment continuously becomes past. The future continuously becomes present. Nothing remains in the now except the immediate experience of now itself, which is constantly refreshing. But here's the twist. In the block universe view, events don't cease to exist when they're past. They remain as locations in spacetime. Your past experiences are still real, just at different temporal coordinates than your present experience. The present isn't more real than the past. It's just where you currently are. This creates an interesting tension. From your perspective embedded in time, impermanence is undeniable. Things pass. Moments end. The now is constantly leaving you. But from the block universe perspective, nothing is impermanent because all events exist eternally in spacetime. Which view is correct? Perhaps both. From within time, you experience impermanence because you move through time, leaving past moments behind and approaching future moments. But from outside time, a perspective you don't have, all moments exist simultaneously and eternally. This suggests that impermanence is a feature of temporal experience, not of spacetime itself. The universe doesn't change. Spacetime is fixed, eternal, unchanging. But your position within spacetime changes, or rather, your world line extends through different regions of spacetime. And this creates the experience of change, flow, impermanence. Can you accept impermanence while recognizing that, in another sense, nothing is lost? Your past exists. It's still real, just elsewhere in spacetime. You can't return to it because your world line extends forward, not backward. But it hasn't been destroyed. It's permanent in spacetime even as it's impermanent in your experience. This might not ease the sting of loss. Knowing that a past moment still exists in spacetime doesn't make it accessible. But it might reframe impermanence. Things don't vanish. They just move out of your present as you move through time. The universe retains everything. It's just that you don't. And now, as consciousness fades towards sleep, consider what happens to your experience of time. During sleep, especially deep sleep, you lose temporal continuity. You don't experience the passing of time. Hours can pass in what seems like an instant. You fall asleep and then you wake up with no sense of duration in between. This is interesting from a relativity perspective. If time dilation makes time pass differently for different observers, sleep makes time cease to pass experientially. You experience no duration. If pressed, you might say that sleep feels instantaneous. You close your eyes and immediately open them, yet hours have elapsed. But time was passing. Your body aged. Your cells metabolized. Your brain went through sleep cycles. Physical processes continued at their normal rate. Time didn't stop. You just stopped experiencing it. This reveals that the experience of time passing and time actually passing are distinct. Time can pass without being experienced. And when it's not experienced, it's as if it didn't pass from your subjective perspective. This is why sleep can feel instantaneous. The duration exists objectively but not experientially. In a sense, sleep is a daily reminder that time is not identical with the experience of time. Time is a physical dimension that exists whether you perceive it or not. Your experience tracks time but is not constitutive of it. This is similar to how relativity shows that time is not universal but exists differently for different observers. Both point toward time being more objective and less tied to consciousness than it initially seems. As you fall asleep tonight, you'll experience this temporal dissolution directly. Your sense of time passing will fade. Duration will cease to be experienced. And then you'll wake, and time will have passed without you experiencing it. This is normal, something you've experienced countless times. But perhaps tonight you can notice it more carefully. The moment when time ceases to be experienced. The transition from present awareness to unconsciousness. And then the abrupt return of awareness upon waking, with no sense of intervening duration. This is your nightly encounter with the gap between experienced time and physical time. And in this gap, maybe there's a hint of what relativity tells us. That time is not what it seems. It's not the universal, absolute, experienced flow we intuitively believe. It's relative, local, frame-dependent. And it continues whether we experience it or not, at rates that vary depending on motion and gravity, in ways we can measure but never directly feel because we're always synchronized with our own local time. Think about astronauts on the ISS as they sleep. Their time is running slightly slower than yours due to their velocity and altitude. But they sleep normally. Their sleep cycles proceed at their local rate. They dream at their local pace. They wake after what feels like a normal night's sleep, even though slightly less time has passed for them than for you on Earth. Does their sleep feel different because time is dilated? No. Sleep feels like sleep. The duration of unconsciousness feels the same to them as it does to you, even though objectively less of their time passes. This is the theme we've explored all night. Time dilation is real but imperceptible from within. Even something as subjective as sleep doesn't reveal the dilation because sleep itself is calibrated to local time. And what about someone falling into a black hole? As they approach the event horizon, time dilates toward infinity relative to external observers. But they continue to sleep and wake according to their local time. Their circadian rhythms continue. Their sleep cycles proceed. They might sleep for what feels like 8 hours, then wake, then sleep again, all while external time races forward at an incomprehensible rate. From outside the black hole, it might seem like they're frozen mid-sleep for eternity. But from inside their reference frame, they're sleeping and waking normally, time passing normally, until they reach the singularity. Sleep doesn't care about time dilation. It proceeds according to local biological clocks, which always tick at what feels like normal rates. This suggests something about the relationship between consciousness and time. Consciousness constructs temporal experience from physical processes that themselves occur in time. When you're awake, these processes create the sense of time passing. When you're asleep, these processes either shut down or operate below the threshold of awareness, so you don't experience duration even though duration is passing physically. Time dilation affects the physical processes but not the experience they generate, when they generate any. Your brain cells fire at their local rate whether you're awake or asleep, whether you're moving fast or slow, whether you're in strong gravity or weak. The firing creates temporal experience when you're conscious. The firing proceeds without creating experience when you're unconscious. But either way, the rate feels normal when it feels like anything because it's always relative to itself. As you prepare to sleep now, you're about to experience this dissolution. You won't feel time stopping or slowing. You'll just stop feeling time at all. And when you wake, you might be surprised by how much time passed. It felt like a moment. You might think, even though hours elapsed. Or it felt like forever, even though you slept briefly. Sleep distorts duration perception because it removes the neural processes that create that perception. This is your nightly experiment in experiencing time's absence. You don't experience time dilation. That requires different reference frames, which you're not in. But you do experience temporal discontinuity, the gap where time passes but isn't experienced. And this gap reveals something true about time. It's independent of consciousness, flowing or at least existing, whether witnessed or not. Now finally, release these thoughts. Let go of relativity. Let go of time dilation. Let go of space-time and world lines and reference frames. Let go of the attempt to understand time's nature. Just let time be what it is in this moment, the immediate, flowing present. You don't need to understand time to experience it. You've been experiencing time your entire life without knowing relativity. The physics doesn't change the phenomenology. Time feels like time regardless of whether you know it's relative. In fact, the physics confirms the phenomenology in a strange way. Time feels like it passes at one rate, your local rate, and physics says it does pass at one rate relative to your frame. The feeling is accurate. It's just not universal. Time passes at the rate you experience it passing, and that rate is as real as any rate can be, even if it's different from someone else's rate. So let understanding fall away. Let concepts dissolve. Return to direct experience. What is it like right now to exist in time? Not to think about time, but to be in time, to experience duration, to feel the present moment as it is without interpretation. This is where all the physics leads anyway. Relativity describes time's behavior, how it curves, how it dilates, how it relates to space. But your experience of time is more fundamental than any description. You are the one existing in time. The theories are just maps. The territory is this immediate now, and the now is strange. It seems to move, advancing from past toward future, carrying you with it. Yet physics says there's no absolute flow. The equations work equally well with time running forward or backward. So is the flow real or illusory? Maybe it's both. The flow might not be fundamental to physics, but it's fundamental to consciousness. Being conscious just is experiencing yourself moving through time, having a perspective from within temporal sequence rather than outside it. The flow is real for you even if it's not real for physics. Your reality and physical reality are different kinds of reality, both valid in their domains. Or maybe the flow is a useful fiction that consciousness creates to make sense of memory and causation. You remember the past, not the future. Causes precede effects. This creates a natural temporal orientation, a sense of direction from earlier to later. And consciousness interprets this orientation as flow, as movement through time. But the flow itself might not be real, just a convenient metaphor for the actual structure of memory and causation. Does it matter which interpretation is correct? Right now, as sleep approaches, probably not. The flow feels real. That's enough. Whether it's fundamental or constructed, whether it's physical or phenomenological, whether it's universal or local, these questions fade as consciousness fades. What remains is just this, the present moment, however you understand it. You're here, you're now, your immediate experience. And this is indisputable. Even if everything else is uncertain, the nature of time, the reality of flow, the existence of other minds, your present experience is certain. It's the one thing you cannot doubt because it's the very thing doing the doubting. So rest in this certainty. The now is real. Your experience is real. Time, whatever it ultimately is really passing or really existing or really being traversed by your consciousness. The details matter for physics, but for living, what matters is that you're here, now, experiencing this moment. And as you let go of questions and concepts, as thinking subsides and sleep approaches, time becomes simple again. It's just now, always now. Past is memory, future is imagination, but now is experience. And that's all you need. Let the now be enough. Let this moment be sufficient. Let time carry you into sleep without resistance. You don't control time's passage. You can't slow it down or speed it up from your perspective. You can only be in it, experiencing it as it flows or exists or structures your experience. And it does flow, or at least it feels like it flows. Whether this flow is real or illusory, whether time is absolute or relative, whether duration is fundamental or emergent, None of this matters as consciousness fades. The theories dissolve. The questions recede. Only the immediate experience remains. And then even that fades. Awareness dims. Thoughts slow. The sense of duration itself becomes uncertain. And finally, sleep comes, and with it, the cessation of temporal experience. Time continues, but you stop tracking it. Duration passes, but you don't experience it passing. Before sleep claims you fully, perhaps one last thought. A gratitude for temporal experience itself, strange and relative as it is. You've spent this time exploring how time works, learning that it's not what intuition suggests, discovering that duration is relative and simultaneity is frame-dependent and the present is local rather than universal. All of this is strange and counterintuitive, but it's also wonderful. You exist in a universe where time is flexible, where different paths through space-time accumulate different durations, where your experience of time is valid even if it's not absolute. This is a richer, more complex, more interesting universe than the simple one of absolute time. You can move through space and thereby affect how much time you experience. You can travel to the future by taking a high-speed journey or spending time in strong gravity. The universe permits time travel of a sort, not to the past but to the future, not through exotic machinery but through simple motion. This is remarkable, and throughout any such journey, time would feel normal to you. This is perhaps even more remarkable. The universe is structured such that your experience is always calibrated to your local reality. You never feel time dilating because you dilate with it. You never feel duration stretching because your perception stretches proportionally. You're always synchronized with yourself, always experiencing 1 second per second of your own time. This synchronization is a gift. Imagine if you could feel time dilation if moving fast made time feel slow. It would be deeply disorienting. Every velocity change would alter duration perception. Flying in an airplane would make hours feel like days. Riding in a car would distort time. Life would be temporal chaos. But instead, time always feels normal. Whatever your velocity, whatever your gravitational environment, whatever your motion through space-time, time passes at the rate time passes for you, and that rate feels like the right rate, the only rate, the normal rate. This is automatic, built into the structure of space-time and consciousness. You don't have to do anything to maintain synchronization. It just happens. This is worth gratitude. Time works in a way that permits varied experiences while maintaining internal consistency. The astronauts age differently than you, but they don't feel it. The traveler at light speed experiences less time than Earth, but doesn't notice. The person near a black hole lives through hours while millennia pass outside, but those hours feel like normal hours. Everyone gets to experience time as normal, as real, as flowing or existing or structuring experience in the usual way. The relativity doesn't create discord at the experiential level. It only appears in comparisons, in measurements, in careful thought. But direct experience remains trustworthy. Your sense of duration is accurate for you. Your experience of time is veridical in your frame. So be grateful for temporal experience, for the fact that you experience time at all, that you have a present moment, that duration has a felt quality, that seconds feel like seconds and hours feel like hours. This is not guaranteed. Time could have been structured differently, in ways that made experience impossible or chaotic. But instead, it's structured to permit stable, consistent, meaningful experience. And be grateful for relativity, for the fact that time is flexible rather than rigid, relative rather than absolute, locally varying rather than universally fixed. This flexibility is what allows time travel to the future, what makes GPS work, what creates fascinating philosophical puzzles about simultaneity and duration. It makes the universe more interesting, more surprising, more worthy of wonder. Tomorrow, when you wake, you'll have experienced several hours of sleep. Time will have passed without your awareness. You'll have aged slightly, Your cells will have gone through their maintenance cycles. Your brain will have consolidated memories and pruned synaptic connections. All of this happens in time, measured by your local clocks, proceeding at your local rate. And you'll wake feeling refreshed, hopefully, ready to experience more time. More nows, more duration, more temporal flow or existence or structure. And all of that time will feel normal, as time should, as time must, because you're always synchronized with your own time frame. This is the gift of relativity. Not that time is complicated, though it is, but that despite its complication, your experience remains simple and consistent and trustworthy. Time is relative, but you don't have to think about that. Time just is flowing or existing or whatever time does, and you experience it as you should. One moment after another, each feeling real, each feeling present while it's present. Be grateful. Sleep in gratitude. And let time take you into its next phase, the phase of unconsciousness, where time passes but isn't experienced, where duration continues but awareness ceases, where you remain in time without knowing it until morning brings the return of temporal experience. Good night. Let time take you into unconsciousness. Trust that you'll wake in the morning, that time will have passed while you slept, that the universe will have continued its evolution whether you witnessed it or not. Time doesn't need your attention to exist. It proceeds independently, at rates that vary with motion and gravity, in ways you can never directly perceive because you're always moving through your own time at the rate your own time flows. Sleep in the knowledge that time is stranger than it seems, but also exactly what it feels like. Both are true, and both are fine. Reality contains paradoxes when you look closely, but experience remains simple. Time passes, you age, you sleep, you wake, and that's enough. The astronauts are sleeping now, aging imperceptibly slower than you. They don't feel it. They dream their dreams, sleep their sleep, wake their waking, all in their own time, which runs at its own rate, different from yours but equally real, equally valid, equally normal from within. Somewhere, in principle, someone could be falling into a black hole, experiencing minutes while outside the horizon millennia pass. They don't feel the discrepancy. Their minutes feel like minutes. Their thoughts proceed at normal speed. Their consciousness flows normally. Only by comparison with external clocks would the difference appear. But there are no external clocks available to them. All signals from outside are blue-shifted and compressed. All signals to outside are red-shifted and dilated. They're isolated in their reference frame, experiencing time locally, as you are experiencing time locally, as everyone must experience time locally because that's the only way experience works. And you're about to stop experiencing time. Not because time will stop, it won't, but because consciousness will cease, and with it, temporal experience. Time will continue for your body, your cells, your atoms. Physical processes will proceed at their local rates, but you won't witness any of it. You'll be unconscious, absent from time experientially while remaining in time physically. This is the paradox of sleep. You remain temporal, aging, changing, persisting through time, but you're not conscious of time. You don't experience its passing. For you, subjectively, sleep is instant. Close eyes, open eyes, no time in between from your perspective. Yet objectively, hours passed. You crossed temporal duration without experiencing the crossing. And this is fine. This is normal. This happens every night. You don't need to experience all time. You don't need to witness every moment. Consciousness can take breaks from temporal experience. The breaks don't make time less real. They just make consciousness intermittent. So let go. Stop experiencing time. Stop witnessing now. Stop tracking duration. Let consciousness fade, and with it, temporal experience. Time will continue. You'll continue physically, but experientially you'll be absent until morning. And in that absence, nothing is lost. You don't miss anything important by sleeping. The universe doesn't require your observation. Time doesn't need your witness. Everything proceeds without you just fine. And when you return to consciousness, when temporal experience resumes, you'll find time exactly as you left it, flowing or existing or structuring experience in the usual way. Rest now. Let go of time. Let go of understanding. Let go of now itself. And drift into the timeless space of sleep, where duration ceases to be experienced even as it continues to pass, where the physics of relativity and the phenomenology of consciousness finally part ways, and where you can rest from the burden of existing in time. Sleep in relative time. Dream in local duration. Wake in your own present. And know that throughout, time was doing what time does, passing at the rate appropriate to your reference frame, structuring your experience when you're conscious, continuing independently when you're not, always real, always relative, always exactly what it needs to be for you to exist, age, sleep, wake, and eventually cease. Good night. Time is relative, but sleep is universal. Rest well in your local time frame, aging imperceptibly, experiencing no duration, present in time without experiencing presence, continuing your journey through space-time even as awareness of that journey fades. The universe is large. Time is relative. Your frame is local. Your experience is real. And that's everything you need to know as consciousness releases its grip and sleep arrives to carry you through several hours of time you won't experience, won't remember, won't witness, but will nonetheless traverse, aging normally by your local clock, existing persistently in your local frame, being in time without knowing it. Good night. Sleep in the peace of relative time, and wake to discover that time passed normally, as it always does, as it must, in the only way time can pass. At the rate your local clock measures, synchronized with your experience when conscious, independent of your experience when not, always real, always relative, always now when you're experiencing it. This might not ease the sting of loss. Knowing that a past moment still exists in space-time doesn't make it accessible. But it might reframe impermanence. Things don't vanish. They just move out of your present as you move through time. The universe retains everything. It's just that you don't. And now, as consciousness fades towards sleep, consider what happens to your experience of time. During sleep, especially deep sleep, you lose temporal continuity. You don't experience the passing of time. Hours can pass in what seems like an instant. You fall asleep and then you wake up with no sense of duration in between. This is interesting from a relativity perspective. If time dilation makes time pass differently for different observers, sleep makes time cease to pass experientially. You experience no duration. If pressed, you might say that sleep feels instantaneous. You close your eyes and immediately open them, yet hours have elapsed. But time was passing. Your body aged. Your cells metabolized. Your brain went through sleep cycles. Physical processes continued at their normal rate. Time didn't stop. You just stopped experiencing it. This reveals that the experience of time passing and time actually passing are distinct. Time can pass without being experienced. And when it's not experienced, it's as if it didn't pass from your subjective perspective. This is why sleep can feel instantaneous. The duration exists objectively but not experientially. In a sense, sleep is a daily reminder that time is not identical with the experience of time. Time is a physical dimension that exists whether you perceive it or not. Your experience tracks time but is not constitutive of it. This is similar to how relativity shows that time is not universal but exists differently for different observers. Both point toward time being more objective and less tied to consciousness than it initially seems. As you fall asleep tonight, you'll experience this temporal dissolution directly. Your sense of time passing will fade. Duration will cease to be experienced. And then you'll wake, and time will have passed without you experiencing it. This is normal, something you've experienced countless times. But perhaps tonight you can notice it more carefully. The moment when time ceases to be experienced. The transition from present awareness to unconsciousness. And then the abrupt return of awareness upon waking, with no sense of intervening duration. This is your nightly encounter with the gap between experienced time and physical time. And in this gap, maybe there's a hint of what relativity tells us. That time is not what it seems. It's not the universal, absolute experience flow we intuitively believe. It's relative, local, frame-dependent. And it continues whether we experience it or not, at rates that vary depending on motion and gravity, in ways we can measure but never directly feel because we're always synchronized with our own local time. Now finally, release these thoughts. Let go of relativity. Let go of time dilation. Let go of space-time and world lines and reference frames. Let go of the attempt to understand time's nature. Just let time be what it is in this moment, the immediate flowing present. You don't need to understand time to experience it. You've been experiencing time your entire life without knowing relativity. The physics doesn't change the phenomenology. Time feels like time regardless of whether you know it's relative. So let understanding fall away. Let concepts dissolve. Return to direct experience. What is it like right now to exist in time? Not to think about time, but to be in time, to experience duration, to feel the present moment as it is without interpretation. This is where all the physics leads anyway. Relativity describes time's behavior, but your experience of time is more fundamental than any description. You are the one existing in time. The theories are just maps. The territory is this immediate now. And as you let go of maps and concepts, as thinking subsides and sleep approaches, time becomes simple again. It's just now, always now. Past is memory, future is imagination, but now is experience. And that's all you need. Let the now be enough. Let this moment be sufficient. Let time carry you into sleep without resistance. You don't control time's passage. You can't slow it down or speed it up from your perspective. You can only be in it, experiencing it as it flows. And it does flow, or at least it feels like it flows. Whether this flow is real or illusory, whether time is absolute or relative, whether duration is fundamental or emergent, none of this matters as consciousness fades. The theories dissolve. The questions recede. Only the immediate experience remains. And then even that fades. Awareness dims. Thoughts slow. The sense of duration itself becomes uncertain. And finally, sleep comes, and with it, the cessation of temporal experience. Time continues, but you stop tracking it. Duration passes, but you don't experience it passing. Let time take you into unconsciousness. Trust that you'll wake in the morning, that time will have passed while you slept, that the universe will have continued its evolution whether you witnessed it or not. Time doesn't need your attention to exist. It proceeds independently, at rates that vary with motion and gravity, in ways you can never directly perceive because you're always moving through your own time at the rate your own time flows. Sleep in the knowledge that time is stranger than it seems, but also exactly what it feels like. Both are true, and both are fine. Reality contains paradoxes when you look closely, but experience remains simple. Time passes, you age, you sleep, you wake, and that's enough. Rest now. Let go of time. Let go of understanding. Let go of now itself, and drift into the timeless space of sleep, where duration ceases to be experienced even as it continues to pass, where the physics of relativity and the phenomenology of consciousness finally part ways, and where you can rest from the burden of existing in time. One final practical consideration: uncertainty. Relativity introduces new kinds of uncertainty beyond ordinary ignorance. You're uncertain about distant events' temporal relation to your present due to simultaneity relativity. You're uncertain about how much coordinate time will pass in other frames during your proper time due to time dilation. You're uncertain about global temporal order when observers in different frames disagree. But these physical uncertainties don't practically matter much because you're embedded in your own frame with your own proper time. What happens in other frames during coordinate time you're not experiencing doesn't affect you directly. You navigate through your own proper time, experiencing your own sequence of events, largely independent of coordinate time in other frames. The more relevant uncertainty is ordinary temporal uncertainty. You don't know what will happen next. Even if the future already exists in block universe, you don't have epistemic access to it. You must navigate forward through time without complete knowledge of what's coming. This uncertainty is unavoidable and actually beneficial. If you knew everything that would happen, decision-making would be pointless. Choices require uncertain outcomes to be meaningful. Anticipation requires unknown future to be possible. Hope requires uncertainty about what's coming. So embrace temporal uncertainty. Don't wish for complete knowledge of the future. The uncertainty is what makes life dynamic, what makes choices matter, what makes each moment potentially surprising. You're navigating unknown temporal territory, and that's exactly as it should be. Relativity doesn't eliminate this uncertainty. Even if it suggests your future already exists, it doesn't give you access to that information. You remain epistemically limited, experiencing time sequentially, learning what happens only as it happens from your perspective. This epistemic limitation is built into temporal existence and isn't overcome by relativity's metaphysics. So live with the uncertainty, plan as best you can, make wise choices with limited information, but accept that you can't know everything about what's coming. The future unfolds as you navigate into it, moment by moment, revealing itself only as you arrive. This is the structure of temporal experience, preserved regardless of whether block universe is correct or time genuinely flows or simultaneity is relative. While time dilation is negligible in everyday life, being aware of it can provide interesting perspective on experience and choices. For instance, understanding that time literally passes differently at different altitudes might make you appreciate time spent at high elevations differently. Those mountain vacations aren't just psychologically refreshing, you're also experiencing slightly faster proper time, aging microseconds more than you would at sea level. Similarly, understanding that motion slows time might reframe how you think about travel. Every flight you take, every fast drive involves tiny amounts of time dilation. You're experiencing slightly less proper time than stationary observers. This is imperceptible, but it's real. You're navigating through spacetime in ways that accumulate different amounts of proper time than people who stay still. This awareness can create a kind of temporal mindfulness. You're not just moving through space, you're also navigating time in complex ways. Your path through spacetime is unique, accumulating proper time at rates that vary slightly based on your velocity and gravitational environment. No one else follows exactly your path or accumulates exactly your proper time. Your temporal experience is genuinely yours. This also applies to life choices involving speed and altitude. If you're choosing between careers, one involving frequent flying, another based at sea level, you're not just choosing different activities but different temporal experiences. The frequent flyer accumulates proper time at a slightly different rate than the ground-based worker. Over a career, this amounts to microseconds, but it's a real physical difference in how much proper time you experience. Does this matter? Not practically. Microseconds are negligible. But conceptually, it's interesting. Your life choices shape not just what you experience, but how much proper time you accumulate experiencing it. You're choosing your path through space-time, not just your path through space. And different paths accumulate different durations even when they span the same coordinate time. This perspective might make you more aware of time as resource. Your proper time is limited, your lifespan measured in your own frame. Every choice about how to spend time is a choice about which path through spacetime to follow, which world line to trace. And while all paths accumulate roughly similar proper time, the variations are tiny. The experiences along those paths differ vastly. So choose your world line wisely. Not to maximize proper time, you can't significantly alter that. but to maximize meaningful experience per unit proper time. Fill your limited duration with experiences worth having. Navigate toward paths through spacetime that enrich your journey. This is temporal wisdom informed by relativity. Understanding that time is your proper time, path-dependent and uniquely yours, makes you more intentional about how you spend it. Perhaps the most practical implication of relativity is recognizing the primacy of the present moment. Your present is the only time that's absolutely definite for you. Past is fixed but inaccessible except through memory. Future is unknown and inaccessible except through anticipation. Only present is immediate, direct, the actual temporal location you inhabit. Relativity reinforces this by showing that simultaneity is relative. Distant events that you consider present might be past or future from other perspectives. But your local present, right here, right now, in your immediate vicinity, is unambiguous. This is genuinely your present, the temporal coordinates where you exist at this moment. This makes present moment awareness both psychologically wise and physically grounded. Meditation traditions have long taught focusing on present, letting go of past and future. And relativity adds that the present is metaphysically special in a way that past and future aren't. It's where you actually are temporally, the point on your world line corresponding to current experience. Practicing present moment awareness means repeatedly returning attention to current experience. When mind wanders to past or future, gently bring it back to present. Not because past and future aren't real, they are in spacetime, but because present is where you actually exist. You can think about past and future, but you can only be in present. This practice becomes easier with understanding of time's nature. You're not trying to force yourself to stay in an arbitrary temporal location. You're recognizing the temporal location where you actually are and choosing to stay aware of it rather than mentally inhabiting memories or projections. Present is your real position in spacetime. Everything else is mental rather than actual. As consciousness prepares for sleep, this present moment awareness becomes simpler. Thinking slows. Complex temporal awareness fades. You're left with bare present. This sensation, this breath, this dimming awareness. And then even that dissolves as sleep arrives and present moment consciousness temporarily ceases. This nightly practice of letting go into sleep is training for letting go generally. Releasing control, accepting what is, inhabiting present fully until consciousness releases even that. Sleep is both metaphor and practice for living with time. Navigating present moment by present moment, letting each moment arise and pass, finally letting awareness itself fade when it's time to rest. One final perspective, gratitude. You exist in time. This is not guaranteed or necessary. The universe could have existed timelessly as a static structure. But it doesn't. Time is real, duration accumulates, change occurs. And this temporal structure makes your existence possible. Without time, no experience. Consciousness requires duration to unfold. Thoughts require time to form. Experiences require time to occur. Everything about being alive depends on time's existence and your navigation through it. Time is the medium of all that you are and experience. So there's reason for gratitude. Not for time being exactly as you might prefer. You can't control time's nature or passage. But for time existing at all, making your existence possible. The universe could have been different in ways that precluded temporal experience. But it isn't. Time is real, you exist in it, and this enables everything you are. Relativity might make time stranger than intuition suggests. Relative, variable, observer-dependent. But this strangeness doesn't diminish the gift of temporal existence. If anything, it makes it more interesting. You're not just existing in simple, absolute time. You're navigating complex, relative space-time, accumulating proper time along your unique world line, experiencing duration in ways specific to your path. This complexity is part of the richness of existence. Simple time would be simpler to understand but less interesting to inhabit. Relative time creates possibilities, time dilation, different reference frames, paths through spacetime with different proper time accumulation. These aren't just mathematical curiosities, but features of the actual temporal medium you live in. So appreciate temporal existence in its full complexity. Time is strange, relative, not fully comprehensible from within. But it's real, it's yours to experience, and it's the dimension that makes your life possible. However much proper time you have, decades or centuries, it's the substrate of all your experiences, relationships, thoughts, and growth. Be grateful for time, even time that passes too quickly or slowly, even time that's relative and observer-dependent, even time that will eventually end. It's what you have, and it's enough. One of the hardest aspects of living in time is accepting that you can't control it. Time passes at the rate it passes from your perspective. You can't slow it down or speed it up experientially. You can't stop it or reverse it or skip ahead. You're carried along your world line whether you consent or not. Relativity shows that time's rate varies with reference frame, but you can't change your reference frame at will. You could accelerate to high velocity or enter strong gravity to experience time dilation, but this requires external means, spacecraft, black holes, not mental control. From within your own frame, time always flows at the same experiential rate, 1 second per second of your proper time. This lack of control is frustrating when time seems to pass too quickly. Precious moments end too fast. Happy periods seem brief. Life feels short. You wish you could slow time down, extend good experiences, make valuable times last longer. But you can't. Time proceeds at its invariable experiential rate, carrying you forward whether you're ready or not. It's also frustrating when time seems too slow. Difficult periods drag on. Unpleasant experiences feel extended. Waiting is tedious. You wish you could speed time up, skip past hard parts, fast forward to better times. But you can't. You must experience every moment at the pace proper time accumulates. As sleep approaches, there's an opportunity to practice releasing control over time. Sleep itself is a surrender. You let go of wakeful consciousness and allow unconscious processes to take over. You can't force sleep or control its depth or determine its duration precisely. You release control to natural processes. This is good practice for releasing control over time generally. Time passes independently of your preferences. You can't make it go faster or slower experientially. You can't stop aging or delay death or freeze special moments. Time carries you forward through your proper duration at the rate that proper time flows, and that rate feels constant from your perspective regardless of coordinate time in other frames. Accepting this means accepting temporal helplessness. You're powerful in many ways. You can choose actions, shape circumstances, influence outcomes. But you're powerless over time's passage. It flows independently, unaffected by your desires or efforts. This is humbling but also freeing. Since you can't control time, you're released from responsibility for it. You just need to navigate through it as wisely as possible given its inexorable flow. So release control. Stop trying to slow down good times or speed up bad times. Stop wishing you could return to past or skip to future. Accept that time moves at the rate it moves, carrying you through proper duration you can't alter. This acceptance brings peace because it stops the futile struggle against something unchangeable. And in sleep, you'll experience time's passage without being conscious of it. Hours will pass that feel like nothing from your perspective. You'll go to sleep and wake with no sense of intervening duration. This is time flowing without experiential tracking, a reminder that time is independent of consciousness even though consciousness requires time. Let time do what it does. Flow, carry you forward, accumulate proper duration, age your body, change circumstances. You can't stop it. You can't control it. You can only experience it as it happens, moment by moment, now to now to now. And that's enough. Time doesn't need your management. It just needs your presence within it. Here's a specific practice for the moments before sleep. Accepting your temporal situation completely. Not just intellectually understanding, but emotionally accepting where you are in time. You are exactly the age you are. Not younger, not older. This precise age with this specific history and this particular amount of proper time accumulated. Can you accept this without wishing you were younger or fearing you're older? Your age is fact, unchangeable, part of your world-line structure. Resisting it is resisting reality. You are at exactly this moment in your life. Not earlier when things were different, not later when things might improve. This specific moment with these circumstances. Can you accept this without dwelling on past or projecting into future? This moment is where you actually are temporally. Wishing you were elsewhere in time is rejecting your actual location. You have exactly the amount of life remaining that you have. Unknown quantity, uncertain duration, but fixed amount. Can you accept this without anxiety about how much time is left? You can't know, can't change, can't control your remaining duration. All you can do is use it well as it unfolds. Your past is exactly what it was. All your experiences, choices, relationships, events, unchangeable history. Can you accept this without regret or rumination? Your past exists at its space-time coordinates, fixed and eternal if block universe is correct. You can't modify it. You can only accept that it happened as it did. Your future is exactly what it will be. Unknown content but determined trajectory. Can you accept this without excessive worry or false certainty? Whether the future already exists or remains open, you don't know what it contains. Acceptance means navigating toward it without demanding advanced knowledge. This practice is simple but profound. Just accepting your temporal situation fully. Your age, your moment, your past, your future, your remaining time. All exactly as they are. Not resisting, not wishing they were different, not mentally struggling against temporal facts. Just accepting. And in this acceptance, finding peace. Temporal struggle creates suffering. Wishing you were younger, regretting past, fearing future, resisting time's passage. Temporal acceptance creates peace. Being present to your actual temporal situation without resistance. As sleep approaches, practice this acceptance. You are where you are in time. This is your proper time accumulation, your world-line position, your temporal coordinates. It's not wrong or right, not good or bad. It just is. And accepting it allows consciousness to rest without temporal conflict. Tomorrow you'll wake at a different temporal position. More proper time will have accumulated. You'll be slightly older, slightly further along your world line. But you'll still be exactly where you are temporally, always in the present of your own experience, always navigating one moment after another. The practice of temporal acceptance continues. It's not once but ongoing, a constant returning to acceptance of temporal reality as it is. And now, finally, consciousness dissolves toward sleep. What is sleep from the perspective of time? Physically, time continues, your body ages, cells function, proper time accumulates. But experientially, time ceases. You lose awareness of duration. Hours pass that feel like nothing. This is your nightly return to timelessness. Not literally, you still exist in time physically. But experientially, you exit the flow of time. You stop tracking duration. The sense of time passing suspends. And when you wake, time has jumped forward with no experiential content filling the gap. Sleep is practice for death in this sense. Both involve cessation of temporal experience. Both are discontinuities in consciousness where time passes but isn't experienced. The difference is that sleep is temporary. Consciousness returns tomorrow. Death is permanent, your world line ends, temporal experience ceases finally. But every night you practice dying. You let consciousness go. You release temporal awareness. You surrender to processes beyond your control. And you trust that you'll return, that time will have passed, that tomorrow's present will feel as real as today's. This trust is profound. You can't guarantee you'll wake. Sleep is risk, letting go of consciousness without certainty it will return. Yet you do it every night because you must. Consciousness needs rest from its temporal burden, from constantly tracking duration and anticipating future. So let go now one more time. Release awareness. Allow time to pass without experiencing it. Trust that physical time continues even as experiential time stops. Your world line extends through sleep, accumulating proper time whether you're conscious or not. In this letting go, perhaps there's a glimpse of time's true nature. It's not fundamentally about experience. Experience tracks time but doesn't constitute it. Time is space-time geometry, proper duration along world lines, the medium in which physical processes unfold. Your experience of time is addition to this structure, not its foundation. Sleep reminds you of this every night. Time continues whether you're aware or not. The universe doesn't pause for your unconsciousness. Proper time accumulates. Physical processes proceed. Reality carries on. You're not needed for time to exist. Time is bigger than you, independent of you, indifferent to your experience of it. This might feel diminishing. Your experience doesn't matter to time itself. But it's also liberating. Time doesn't require your constant attention. You can rest. You can stop tracking duration for a while. Time will take care of itself, flowing whether you witness it or not. Good night. Sleep in time that continues without your awareness. Rest in proper duration that accumulates whether experienced or not. And trust that tomorrow you'll wake to the eternal now that is always your present, always your temporal location, always the moment where you exist regardless of how much coordinate time has passed in other frames or how strange time's nature is revealed to be by relativity. Sleep well. Time will carry you through the night. Let time take you into unconsciousness. Trust that you'll wake in the morning, that time will have passed while you slept, that the universe will have continued its evolution whether you witnessed it or not. Time doesn't need your attention to exist. It proceeds independently, at rates that vary with motion and gravity, in ways you can never directly perceive because you're always moving through your own time at the rate your own time flows. Sleep in the knowledge that time is stranger than it seems, but also exactly what it feels like. Both are true, and both are fine. Reality contains paradoxes when you look closely, but experience remains simple. Time passes. You age. You sleep. You wake. And that's enough. Rest now. Let go of time. Let go of understanding. Let go of now itself. And drift into the timeless space of sleep, where duration ceases to be experienced even as it continues to pass, where the physics of relativity and the phenomenology of consciousness finally part ways, and where you can rest from the burden of existing in time. One final practical consideration: uncertainty. Relativity introduces new kinds of uncertainty beyond ordinary ignorance. You're uncertain about distant events' temporal relation to your present due to simultaneity relativity. You're uncertain about how much coordinate time will pass in other frames during your proper time due to time dilation. You're uncertain about global temporal order when observers in different frames disagree. But these physical uncertainties don't practically matter much because you're embedded in your own frame with your own proper time. What happens in other frames during coordinate time you're not experiencing doesn't affect you directly. You navigate through your own proper time, experiencing your own sequence of events, largely independent of coordinate time in other frames. The more relevant uncertainty is ordinary temporal uncertainty. You don't know what will happen next. Even if the future already exists in block universe, you don't have epistemic access to it. You must navigate forward through time without complete knowledge of what's coming. This uncertainty is unavoidable and actually beneficial. If you knew everything that would happen, decision-making would be pointless. Choices require uncertain outcomes to be meaningful. Anticipation requires unknown future to be possible. Hope requires uncertainty about what's coming. So embrace temporal uncertainty. Don't wish for complete knowledge of the future. The uncertainty is what makes life dynamic, what makes choices matter, what makes each moment potentially surprising. You're navigating unknown temporal territory, and that's exactly as it should be. Relativity doesn't eliminate this uncertainty. Even if it suggests your future already exists, it doesn't give you access to that information. You remain epistemically limited, experiencing time sequentially, learning what happens only as it happens from your perspective. This epistemic limitation is built into temporal existence and isn't overcome by relativity's metaphysics. So live with the uncertainty. Plan as best you can. Make wise choices with limited information. But accept that you can't know everything about what's coming. The future unfolds as you navigate into it, moment by moment, revealing itself only as you arrive. This is the structure of temporal experience, preserved regardless of whether block universe is correct or time genuinely flows or simultaneity is relative. While time dilation is negligible in everyday life, being aware of it can provide interesting perspective on experience and choices. For instance, understanding that time literally passes differently at different altitudes might make you appreciate time spent at high elevations differently. Those mountain vacations aren't just psychologically refreshing, you're also experiencing slightly faster proper time, aging microseconds more than you would at sea level. Similarly, understanding that motion slows time might reframe how you think about travel. Every flight you take, every fast drive involves tiny amounts of time dilation. You're experiencing slightly less proper time than stationary observers. This is imperceptible, but it's real. You're navigating through spacetime in ways that accumulate different amounts of proper time than people who stay still. This awareness can create a kind of temporal mindfulness. You're not just moving through space, you're also navigating time in complex ways. Your path through spacetime is unique, accumulating proper time at rates that vary slightly based on your velocity and gravitational environment. No one else follows exactly your path or accumulates exactly your proper time. Your temporal experience is genuinely yours. This also applies to life choices involving speed and altitude. If you're choosing between careers, one involving frequent flying, another based at sea level, you're not just choosing different activities but different temporal experiences. The frequent flyer accumulates proper time at a slightly different rate than the ground-based worker. Over a career, this amounts to microseconds, but it's a real physical difference in how much proper time you experience. Does this matter? Not practically. Microseconds are negligible. But conceptually, it's interesting. Your life choices shape not just what you experience, but how much proper time you accumulate experiencing it. You're choosing your path through space-time, not just your path through space. And different paths accumulate different durations even when they span the same coordinate time. This perspective might make you more aware of time as resource. Your proper time is limited, your lifespan measured in your own frame. Every choice about how to spend time is a choice about which path through spacetime to follow, which world line to trace. And while all paths accumulate roughly similar proper time, the variations are tiny. The experiences along those paths differ vastly. So choose your world line wisely. Not to maximize proper time, you can't significantly alter that, but to maximize meaningful experience per unit proper time. Fill your limited duration with experiences worth having. Navigate toward paths through spacetime that enrich your journey. This is temporal wisdom informed by relativity. Understanding that time is your proper time, path-dependent and uniquely yours, makes you more intentional about how you spend it. Perhaps the most practical implication of relativity is recognizing the primacy of the present moment. Your present is the only time that's absolutely definite for you. Past is fixed but inaccessible except through memory. Future is unknown and inaccessible except through anticipation. Only present is immediate, direct, the actual temporal location you inhabit. Relativity reinforces this by showing that simultaneity is relative. Distant events that you consider present might be past or future from other perspectives. But your local present, right here, right now, in your immediate vicinity, is unambiguous. This is genuinely your present, the temporal coordinates where you exist at this moment. This makes present moment awareness both psychologically wise and physically grounded. Meditation traditions have long taught focusing on present, letting go of past and future. And relativity adds that the present is metaphysically special in a way that past and future aren't. It's where you actually are temporally, the point on your world line corresponding to current experience. Practicing present moment awareness means repeatedly returning attention to current experience. When mind wanders to past or future, gently bring it back to present. Not because past and future aren't real, they are in space-time, but because present is where you actually exist. You can think about past and future, but you can only be in present. This practice becomes easier with understanding of time's nature. You're not trying to force yourself to stay in an arbitrary temporal location. You're recognizing the temporal location where you actually are and choosing to stay aware of it rather than mentally inhabiting memories or projections. Present is your real position in space-time. Everything else is mental rather than actual. As consciousness prepares for sleep, this present moment awareness becomes simpler. Thinking slows. Complex temporal awareness fades. You're left with bare present. This sensation, this breath, this dimming awareness. And then even that dissolves as sleep arrives and present moment consciousness temporarily ceases. This nightly practice of letting go into sleep is training for letting go generally. Releasing control, accepting what is, inhabiting present fully until consciousness releases even that. Sleep is both metaphor and practice for living with time, navigating present moment by present moment, letting each moment arise and pass, finally letting awareness itself fade when it's time to rest. One final perspective, gratitude. You exist in time. This is not guaranteed or necessary. The universe could have existed timelessly as a static structure, but it doesn't. Time is real, duration accumulates, change occurs, and this temporal structure makes your existence possible. Without time, no experience. Consciousness requires duration to unfold. Thoughts require time to form. Experiences require time to occur. Everything about being alive depends on time's existence and your navigation through it. Time is the medium of all that you are and experience. So there's reason for gratitude. Not for time being exactly as you might prefer. You can't control time's nature or passage. But for time existing at all, making your existence possible. The universe could have been different in ways that precluded temporal experience. But it isn't. Time is real, you exist in it, and this enables everything you are. Relativity might make time stranger than intuition suggests. Relative, variable, observer-dependent. But this strangeness doesn't diminish the gift of temporal existence. If anything, it makes it more interesting. You're not just existing in simple, absolute time. You're navigating complex, relative space-time, accumulating proper time along your unique world line, experiencing duration in ways specific to your path. This complexity is part of the richness of existence. Simple time would be simpler to understand but less interesting to inhabit. Relative time creates possibilities, time dilation, different reference frames, paths through space-time with different proper time accumulation. These aren't just mathematical curiosities but features of the actual temporal medium you live in. So appreciate temporal existence in its full complexity. Time is strange, relative, not fully comprehensible from within. But it's real. It's yours to experience. And it's the dimension that makes your life possible. However much proper time you have, decades or centuries, It's the substrate of all your experiences, relationships, thoughts, and growth. Be grateful for time, even time that passes too quickly or slowly, even time that's relative and observer-dependent, even time that will eventually end. It's what you have, and it's enough. One of the hardest aspects of living in time is accepting that you can't control it. Time passes at the rate it passes from your perspective. You can't slow it down or speed it up experientially. You can't stop it or reverse it or skip ahead. You're carried along your world line whether you consent or not. Relativity shows that time's rate varies with reference frame, but you can't change your reference frame at will. You could accelerate to high velocity or enter strong gravity to experience time dilation, but this requires external means: spacecraft, black holes, not mental control. From within your own frame, time always flows at the same experiential rate, 1 second per second of your proper time. This lack of control is frustrating when time seems to pass too quickly. Precious moments end too fast. Happy periods seem brief. Life feels short. You wish you could slow time down, extend good experiences, make valuable times last longer. But you can't. Time proceeds at its invariable experiential rate, carrying you forward whether you're ready or not. It's also frustrating when time seems too slow. Difficult periods drag on. Unpleasant experiences feel extended. Waiting is tedious. You wish you could speed time up, skip past hard parts, fast forward to better times. But you can't. You must experience every moment at the pace proper time accumulates. As sleep approaches, there's an opportunity to practice releasing control over time. Sleep itself is a surrender. You let go of wakeful consciousness and allow unconscious processes to take over. You can't force sleep or control its depth or determine its duration precisely. You release control to natural processes. This is good practice for releasing control over time generally. Time passes independently of your preferences. You can't make it go faster or slower experientially. You can't stop aging or delay death or freeze special moments. Time carries you forward through your proper duration at the rate that proper time flows, and that rate feels constant from your perspective regardless of coordinate time in other frames. Accepting this means accepting temporal helplessness. You're powerful in many ways. You can choose actions, shape circumstances, influence outcomes. But you're powerless over time's passage. It flows independently, unaffected by your desires or efforts. This is humbling but also freeing. Since you can't control time, you're released from responsibility for it. You just need to navigate through it as wisely as possible given its inexorable flow. So release control. Stop trying to slow down good times or speed up bad times. Stop wishing you could return to past or skip to future. Accept that time moves at the rate it moves, carrying you through proper duration you can't alter. This acceptance brings peace because it stops the futile struggle against something unchangeable. And in sleep, you'll experience time's passage without being conscious of it. Hours will pass that feel like nothing from your perspective. You'll go to sleep and wake with no sense of intervening duration. This is time flowing without experiential tracking, a reminder that time is independent of consciousness even though consciousness requires time. Let time do what it does. Flow, carry you forward, accumulate proper duration, age your body, change circumstances. You can't stop it. You can't control it. You can only experience it as it happens, moment by moment, now to now to now. And that's enough. Time doesn't need your management. It just needs your presence within it. Here's a specific practice for the moments before sleep. Accepting your temporal situation completely. Not just intellectually understanding, but emotionally accepting where you are in time. You are exactly the age you are. Not younger, not older. This precise age with this specific history and this particular amount of proper time accumulated. Can you accept this without wishing you were younger or fearing you're older? Your age is fact, unchangeable, part of your world line structure. Resisting it is resisting reality. You are at exactly this moment in your life. Not earlier when things were different, not later when things might improve. This specific moment with these circumstances. Can you accept this without dwelling on past or projecting into future? This moment is where you actually are temporally. Wishing you were elsewhere in time is rejecting your actual location. You have exactly the amount of life remaining that you have. Unknown quantity, uncertain duration, but fixed amount. Can you accept this without anxiety about how much time is left? You can't know, can't change, can't control your remaining duration. All you can do is use it well as it unfolds. Your past is exactly what it was. All your experiences, choices, relationships, events, unchangeable history. Can you accept this without regret or rumination? Your past exists at its spacetime coordinates, fixed and eternal if block universe is correct. You can't modify it. You can only accept that it happened as it did. Your future is exactly what it will be. Unknown content but determined trajectory. Can you accept this without excessive worry or false certainty? Whether the future already exists or remains open, you don't know what it contains. Acceptance means navigating toward it without demanding advanced knowledge. This practice is simple but profound. Just accepting your temporal situation fully. Your age, your moment, your past, your future, your remaining time. All exactly as they are. Not resisting, not wishing they were different, not mentally struggling against temporal facts. Just accepting. And in this acceptance, finding peace. Temporal struggle creates suffering. Wishing you were younger, regretting past, fearing future, resisting time's passage. Temporal acceptance creates peace. Being present to your actual temporal situation without resistance. As sleep approaches, practice this acceptance. You are where you are in time. This is your proper time accumulation, your world line position, your temporal coordinates. It's not wrong or right, not good or bad. It just is. And accepting it allows consciousness to rest without temporal conflict. Tomorrow you'll wake at a different temporal position. More proper time will have accumulated. You'll be slightly older, slightly further along your world line. But you'll still be exactly where you are temporally, always in the present of your own experience, always navigating one moment after another. The practice of temporal acceptance continues. It's not once but ongoing, a constant returning to acceptance of temporal reality as it is. And now, finally, consciousness dissolves toward sleep. What is sleep from the perspective of time? Physically, time continues, your body ages, cells function, proper time accumulates. But experientially, time ceases. You lose awareness of duration. Hours pass that feel like nothing. This is your nightly return to timelessness. Not literally, you still exist in time physically, but experientially, you exit the flow of time. You stop tracking duration. The sense of time passing suspends. And when you wake, time has jumped forward with no experiential content filling the gap. Sleep is practice for death in this sense. Both involve cessation of temporal experience. Both are discontinuities in consciousness where time passes but isn't experienced. The difference is that sleep is temporary. Consciousness returns tomorrow. Death is permanent, your world line ends, temporal experience ceases finally. But every night you practice dying. You let consciousness go. You release temporal awareness. You surrender to processes beyond your control. And you trust that you'll return, that time will have passed, that tomorrow's present will feel as real as today's. This trust is profound. You can't guarantee you'll wake. Sleep is risk, letting go of consciousness without certainty it will return. Yet you do it every night because you must. Consciousness needs rest from its temporal burden, from constantly tracking duration and anticipating future. So let go now one more time. Release awareness. Allow time to pass without experiencing it. Trust that physical time continues even as experiential time stops. Your world line extends through sleep, accumulating proper time whether you're conscious or not. In this letting go, perhaps there's a glimpse of time's true nature. It's not fundamentally about experience. Experience tracks time but doesn't constitute it. Time is space-time geometry, proper duration along world lines, the medium in which physical processes unfold. Your experience of time is addition to this structure, not its foundation. Sleep reminds you of this every night. Time continues whether you're aware or not. The universe doesn't pause for your unconsciousness. Proper time accumulates. Physical processes proceed. Reality carries on. You're not needed for time to exist. Time is bigger than you, independent of you, indifferent to your experience of it. This might feel diminishing. Your experience doesn't matter to time itself. But it's also liberating. Time doesn't require your constant attention. You can rest. You can stop tracking duration for a while. Time will take care of itself, flowing whether you witness it or not. Good night. Sleep in time that continues without your awareness. Rest in proper duration that accumulates whether experienced or not. And trust that tomorrow you'll wake to the eternal now that is always your present, always your temporal location, always the moment where you exist regardless of how much coordinate time has passed in other frames or how strange time's nature is revealed to be by relativity. Sleep well. Time will carry you through the night.